Good morning. My name is Ali Munir, and I am serving as a designated federal official to the U.S. EPA Science Advisory Committee on Chemicals, or the SACC. For this meeting in my role, I will be opening the second day of the public meeting on EPA's 2024 draft risk evaluation for 1,1-dichloroethane and the draft human health hazard assessment for 1,2-dichloroethane. I'd like to repeat that the SACC meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov. See docket number in the meeting agenda. Also, this meeting is being webcasted, transcribed, and recorded. A live stream of today's meeting is available on YouTube. See the link on the meeting website. The website is listed in the agenda, which also has a link to yesterday's meeting. We had a successful opening day yesterday, and I would like to thank the SACC and the ad hoc reviewers and the EPA team for their presentations, and the public also for their public comments and the discussions that we all had yesterday. And now I will hand it over to the chair, Dr. George Cobb. Dr. Cobb?
Thank you, Ali. I also would like to echo my thanks to everyone and look forward to robust discussions today as we start with exposure assessments and move on through hazards as well. So let's start by taking the roll, and then I'll say I'm going to pass the meeting off to Dr. Fox for an hour or so because I'm teaching today, so I'm going to have to log off to do that for about an hour. But let's go ahead and get started. Dr. Apte.
Hi, this is Udayan Apte from University of Kansas Medical Center.
All right. Dr. Chason?
Present,
No.
thank you.
Oh, thank you. Dr. Ike?
Good morning. I'm here.
Dr. Fong?
Good morning, present.
Dr. Fox?
Good morning.
I hope you're here.
I'm
you're on the
here.
hot seat today.
I am here.
Dr. Gentry? I see.
Good
Cynthia.
morning. I'm here. Good morning.
Let's see. Dr. Jenkins?
Good morning, I'm here. Thanks.
Dr. Lee?
I'm here. Good morning. Thanks.
All right. Dr. Merced Nieves?
Present. Good morning.
Good morning. Dr. Rumpler?
Good morning. I'm present.
Dr. Samuel?
Good morning. Yes, I'm here.
In Mountain Time, no less.
In Mountain Time.
All right. Mr. Wright?
Excuse me. Good morning. I'm here.
All right. Dr. Engel? Dr.
I'm here.
Oh, great. Dr. Hernandez? Okay. Dr. Kaluzhny?
Good morning. I'm here.
Dr. Landis?
I'm here, and the sun is just now officially risen.
On the West Coast.
Yeah.
Ms. Lynch? Ms. Lynch?
North End, yeah.
Hi, good morning. I'm here.
Good to see you today. Dr. Malberti?
Good morning. I'm here.
Dr. Rose?
Good morning. I'm here, and my video is working, so that's
Great.
that's a good thing.
Excellent. Dr. Stice?
Good morning, present.
And is Dr. Zhu with us today? I think he's in a conference. Okay, the only person that didn't answer was Dr. Hernandez. Is he here?
And
All right, well, I
George, you forgot me. Cynthia Graham, I am here.
I thought I called you, Cynthia, but
No, you jumped over me. That's okay.
okay. Well, I had you in my mind because I saw your picture. Okay, so thank you for that. And now we're going to start by asking EPA to provide the responses back from yesterday. There were some items that they had from yesterday. Are you folks ready with that? Is the EPA crew there?
Yes. We're here.
All right. So, yeah, so if you folks will make that presentation, I'm going to have to log off for about an hour, and Dr. Fox is going to be in charge after I say goodbye. But thank you for getting started with this.
It's Janet Burris from EPA in OPPT's Ecological Risk Assessment Division. And I will be reading in the questions, responsive, the questions that the SAC panel asked about yesterday and our responses. So first, the SAC requested confidence intervals for the aquatic hazard data. The response is that the confidence intervals, if available, are added in red text to the table below. Confidence intervals on the model data sourced from WebEyes are available in Appendix K.2.1.1 of the draft risk evaluation. And these changes are being made to table Appendix J-4, which is the empirical acute EC50, LC50, and chronic value hazard comparison for various aquatic species exposed to 1,1-dichloroethane or analogs, 1,2-dichloropropane, and 1,12-trichloroethane. So we have added. The next question, the SAC requested information on the databases and data sources that get searched. The response is that the draft systematic review protocol supporting TSCA risk evaluations for chemical substances, version 1.0, a generic TSCA systematic review protocol with chemical specific methodologies, Hero ID 104-15760, was reviewed by the TSCA Scientific Advisory Committee on Chemicals, the SAC, in 2021 and received public comment. This draft document describes the process used to identify potentially relevant information when conducting a systematic review. Section 4 of the document of Appendix E of the document contains a list and description of databases identified for each discipline. Additional data sources and/or databases evaluated to inform the risk evaluation of 1,1-dichloroethane are described in the draft systematic review protocol for 1,1-dichloroethane systematic review support document for the draft risk evaluation, Hero ID 111511731. The SAC requested information on what is involved in full text screening. At what point is EPA OPPT using artificial intelligence tools, and when are humans reading and evaluating to the studies? The response is sections 4.2.5 and 4.3.2 of the draft systematic review protocol supporting TSCA risk evaluations for chemical substances, version 1.0, a generic TSCA systematic review protocol with chemical specific methodologies, Hero ID 104-15760, and section 4 of the draft systematic review protocol for 1,1-dichloroethane. Systematic review support document for the draft risk evaluation, Hero ID 111-51731, describe how title and abstract screening and full text screening are conducted to identify references that may contain relevant information for use in risk evaluations under TSCA using discipline-specific screening criteria. EPA uses machine learning in the identification and screening of potentially relevant information for risk evaluations. EPA does not use generative AI for this or other purposes in the systematic review process. Full text screening is conducted manually by 2 independent technical experts in a respective discipline. If the independent screeners' responses differ, they may collaborate to resolve the conflict. If the independent screeners cannot reach consensus or encounter situations that may be common to multiple screeners, they may consult discipline-specific experts or the full screening team. Some disciplines, for example, physical and chemical properties, may use a 3rd independent reviewer to resolve conflicts. The SACC requested information on metabolic and toxicologic similarities for the other analogs. Why did EPA OPPT not evaluate toxicological similarities for all assessed possible analogs? The response. The process EPA used to identify an analog for both environmental hazard and human health hazard start with the same step, structural similarity analysis. The analysis were completed using 4 programs. AIM analysis was performed on CBI side, and analogs were described as first or second pass. Tanimoto-based PubChem fingerprints were obtained in the OECD QSAR Toolbox version 4.4.1 2020 using the structural similarity option. Chemical Morgan fingerprint scores were obtained in GenRA version 3.1, a limit of 100 analogs with no ToxRef filter. Tanimoto scores were obtained in the Chem Informatics search module using similar analysis. AIM first and second pass analogs were compiled with the top 100 analogs with indices greater than 0.5 generated from the OECD QSAR Toolbox and the Chem Informatics search module and indices greater than 0.1 generated from GenRA. Analogs that appeared in 3 out of 4 programs were identified as potential analog candidates. Using these parameters, 17 analogs were identified as potentially suitable analog candidates for 1,1-dichloroethane based on structural similarity. Only the results for the structural comparison are shown for chemicals that have completed data evaluation and extraction as part of the OPPT systematic review process, or were previously evaluated by OPPT with final published risk evaluations. This was necessary as it was not possible to complete data evaluation and extraction for all possible analogs and complete the risk evaluation within the required time frame. The SACC requested clarification on the qualitative evaluation versus quantitative evaluation of toxicological similarities as part of the analog selection process mentioned in one of the presentations. The SACC requested to see the qualitative evaluation of the target analog chemicals if it is available. The response. Due to limited human health information for 1,1-dichloroethane, quantitative comparisons between 1,1-dichloroethane and 1,2-dichloroethane are only available for one oral study, which is Maldahara et al. 2001. Evaluation of the entire database of both 1,1-dichloroethane and 1,2-dichloroethane can be found starting in section 5.2.3 and continuing through section 5.2.5. quantitative comparisons of the oral toxicity of 1,1-dichloroethane from this one study to data for 1,2-dichloroethane is shown in section 5.2.6.1.2 to 5.2.6.1.4 for acute, short-term, and chronic oral exposures, respectively. The primary comparisons of toxicological similarities as part of the analog selection process is qualitative. Qualitative comparisons of the oral toxicity of 1,1-dichloroethane compared to 1,2-dichloroethane is detailed in section 5.2.2 for toxicokinetics, section 5.2.3.1 for non-cancer critical health outcomes, section 5.2.4 for genotoxicity, and section 5.2.5.1.1 for cancer. This information is summarized as part of the analog selection process in section 5.2.1.3.4 for cancer and section 5.2.1.3.5 for non-cancer. The SACC requested specific information on where the application of body weight scaling is described in the risk evaluation. The response: the application of body weight scaling in the calculation of human equivalent doses, HEDs, and human equivalent concentrations, HECs, are provided in Appendix M.3.1.3 of the risk evaluation document. The conversion can also be found in tables 5-49 through 5-51 in the footnotes to the 1,1-dichloroethane draft risk evaluation. So that completes the reading.
Yes, thank you. Yes, thank you very much, Janet. If you could please provide a copy of those responses to me as soon as available, so that way I could share that with the committee, that would be great. Thank you.
We will be doing that, yes.
Thank you.
Thank you.
Great, yes, much appreciated. So that was good follow-up from yesterday. I'd also like to ask if our EPA colleagues have any questions for the SACC as follow-up from yesterday.
No.
We do not. We do not.
Okay, great.
Good.
And any questions then also from the SACC members and follow up from yesterday? Okay, I'm not seeing any hands, so I think we can proceed to our charge questions, and we would ask EPA to read in the first charge question for us. Are you still getting set up? We can see the question. I'm not hearing any audio.
Yes, thank you. We're finally set up. So I'll read the first charge question.
Great, go ahead.
All right. Charge question 1. As described in section 2 of the draft risk evaluation, 1,1-dichloroethane is a volatile liquid with appreciable water solubility. Depending on which environmental compartment receives the release, 1,1-dichloroethane is expected to partition primarily to air. However, environmental partitioning analysis shows continuous releases of 1,1-dichloroethane to water have the potential to remain in water. Additional discussion of the evidence of 1,1-dichloroethane in various media, including water, is presented in sections 1.1.2.1 and 2.2.2 of the draft risk evaluation. As described in section 3.3.3.2.1 of the draft risk evaluation, to estimate exposures from releases to surface water for the one facility representing the manufacturing condition of use, EPA used this facility's second highest recorded release, which took place in 2016, as more representative of the release conditions for this facility. The highest release from this facility, located in Lake Charles, Louisiana, was associated with a storm event that is not representative of usual operating conditions and was considered an outlier in the analysis. The analysis includes consideration of the facility's operating days. Second part. However, since extreme storm events do occur with regularity in the region of the country where the manufacturing facility is located and may be expected to occur with higher frequency and intensity in the future due to climate change, EPA is seeking comments on this approach. The analysis also includes consideration of the facility's operating days. Please comment on the use, representativeness, and relevancy of the 2016 annual release data for estimating environmental exposure in the draft risk evaluation via surface water for this facility over its operating days.
Great, thank you for reading in question 1, and I will turn it to our discussants. Allison Jenkins, would you lead us off, please?
Yeah, good morning again. So we have quite a few comments on this charge question, some related directly to the charge question, and then some other comments related to some of the other media. And so I'm going to summarize this, our comments, and then the other discussants can weigh in also with their specific comments. So starting off, the discussants assigned to charge question 1 have different recommendations to the EPA on the question of including high discharge data from 2020 from a facility in Louisiana. Some discussants think the 2020 discharge data should be included, and some do not. The discussants also have some additional comments and information to take into consideration on concentrations of 1,1-DCA in other environmental media and exposure assessments. All of the discussants evaluating charge question 1 would like additional information regarding surface water releases and modeling. We recommend that the risk evaluation includes additional justification, including the actual release amounts from the Westlake facility in Louisiana and additional descriptions of the event surrounding the 2020 release, as was shown in EPA's presentation yesterday. The effects of weather conditions are a serious consideration that should be incorporated into models for hazard and risk in a geographic region. In addition, the projected effects of weather events would be important in proactive prediction of risk to pests, communities, and to ecosystems and wildlife. Given that air is the major pathway for more significant movement of the chemical, given its volatility, there is the question of how significant concentrations of 1,1-DCA get to waterways. Exposure to pest communities nearby manufacturing facilities may be the most at risk. Similarly, green areas and ecosystems wildlife in these areas would also be potentially exposed through air with deposition of 1,1-DCA on soil and in waterways. In an exposure analysis, it is important to consider the range of values that may be released to the environment. It is also important to know the frequency of those values. That information is shown in figures 312 and 313 of the draft risk evaluation. According to figure 312, the extreme event measurements are almost 3 orders of magnitude greater than the tail of what appears to be the typical range of measurements. In figure 313, the extreme event is an order of magnitude greater than the next highest value for the modeled releases. The y-axis of both figures is frequency of occurrence, but the total is much greater than 100%. So it is assumed that the numbers are based on number of observations at each set of concentrations. In looking at figures 312 and 313, one of the discussants had a question, is it correct to assume that the extreme events are the single observations that are the last 3 data points at the highest concentrations? It would have been nice to have the graphs based on percent or probabilities instead. The discussants recommend a discussion of uncertainty in the surface water modeling that should include information on whether the period from 2015 to 2020 is typical, and are there market or other forces that would change production. And given that the number of violent storms in the Gulf region is likely to increase in the near future, are the upper tails of these distributions likely to increase? So for the discussants in favor of using the 2020 release data, the rationale for exclusion of the extreme event is not well developed. The exclusion of extreme data is not unusual in hydrologic and fate and transport analyses. The rationale for excluding the largest release is not well developed and seemingly based only on the release occurring as a result of a hurricane. With this very limited explanation, it is unclear why this decision was made, given hurricane frequency for the location is known and projections are for increased hurricane frequency. If there were other unique conditions resulting in the release that occurred simultaneously with the hurricane, there is potential to make a case to exclude the release from the analyses. Given the increasing regularity of such events due to climate change, the exclusion of this data must be reevaluated. Inclusion of extreme weather-related releases is critical for an accurate risk evaluation. The draft evaluation's exclusion of the largest release of 10,700 pounds of 1,1 DCA during a storm in 2020 significantly underestimates the risk posed by this chemical. Instead, the EPA used that second highest release from 2016 for its risk evaluation. By ignoring storm-related events, the EPA disregards the growing likelihood of extreme weather in Gulf Coast regions like Louisiana, where hurricanes and storm surges are foreseeable and recurring due to climate change. Statistical data supports including extreme weather-related releases. The GAO's 2022 report on EPA's risk management plan found that 31% of the over 10,000 RMP facilities analyzed are located in areas prone to natural hazards such as flooding, hurricanes, and storm surges. The exclusion of storm-related releases disproportionately affects fence-line communities, which are often composed of low-income and minority populations living near hazardous facilities. Ignoring these releases places these vulnerable populations at even greater risk during extreme weather events. Disproportionate impacts on vulnerable communities. Lake Charles, Louisiana, where the largest release of 1,1 DCA occurred, ranks in the 99th percentile nationally for vulnerability to extreme weather events and climate-related deaths. Communities here often lack critical infrastructure and emergency resources to respond to chemical releases during extreme weather, which is compounded by their already disproportionate exposure to toxic chemicals. Climate change is increasing the frequency and severity of natural hazards, especially in regions where hazardous chemical facilities are concentrated. According to NOAA, the frequency of billion-dollar weather and climate disasters has risen sharply. In the 1980s, the U.S. experienced $1 billion disaster every 4 months. From 2018 to 2022, $1 billion disaster occurred every 3 weeks, with a total of 89 climate-related events during this period. There is scientific support for including climate change in risk assessments, and we can provide these publications in our comments. The EPA has also failed to account for other unplanned releases from facilities like the one in Lake Charles, which regularly experiences equipment malfunctions, power outages, and shutdown conditions. According to the Louisiana Environmental Action Network, the EPA did not adequately review data from sources such as the Louisiana Department of Environmental Quality, which reported multiple unplanned releases of 1,1-DCA. By not including these data points, the EPA underestimates the frequency and severity of unplanned chemical releases, which leaves a significant gap in the risk evaluation. To ensure an accurate and comprehensive risk evaluation, the EPA should include storm-related releases and other unplanned events in the risk evaluation of 1,1-DCA. Given that these events are foreseeable and recurring, they should consider the disproportionate impacts on fence-line communities who are more vulnerable to chemicals released during extreme weather events. Review federal and state data on unplanned chemical releases, including those reported by the Louisiana Department of Environmental Quality, to ensure risks are captured in the evaluation. TSCA and the Federal Clean Water Act are distinct regulations. TSCA's evaluation of chemicals like 1,1-DCA could benefit from integrating certain principles from the Clean Water Act's risk determination framework. So those in favor of using the second highest annual release data for a facility in Lake Charles, these are those comments related to that. This approach was intended to produce the most conservative estimate. This approach is appropriate given that it represents the reasonable worst cases under the constraint of data availability. The facility's release from 2020's Category 4 Hurricane Laura is not appropriate to estimate a concentration in surface water that is then used for assessment of general population risk to human health and aquatic life. The discussants recommend that Section 3.3.3.2.1 include the actual release amounts in the text from the Westlake facility and have more description of the events as was shown in the presentation yesterday. Some discussants believe that releases of 1,1-DCA due to natural disasters like storms and floods and accidents are better evaluated separately, for example, as a risk to pests, to prevent miscommunication of general population risks. So that discussion or those comments are about the charge question. Then we have some additional comments on some of the other media. So in section 3.3.3.5, measured concentrations in drinking water. The state of Texas and other states routinely measures public water systems for volatile organic chemicals, including 1,1-DCA. Since, as is stated in the draft risk evaluation, 30% of the facilities that report releases of 1,1-DCA to TRI are in Texas, publicly available data were downloaded for raw and treated samples from the over 5,100 Texas public water systems that monitor routinely for volatile organic compounds or VOCs, including 1,1-DCA. The Texas public water systems include drinking water sources from groundwater, surface water, and groundwater under the influence of surface water. There were no detections of 1,1-DCA in Texas from 2015 to 2020 in raw or treated drinking water. Although as stated in section 5.3.3.2.2, no general population risks were identified for drinking water ingestion or fish ingestion using modeling data. The data from public water systems in Texas and other states were not included or evaluated and are critical to communicate general population risk in addition to the UCMR3 data. Similar to the exposure assumptions for ambient air, it is important to acknowledge that 1,1-DCA is not detected in Texas public water systems, and it's rarely detected in public water systems in the U.S. In the systematic review document for 1,1-DCA, EPA states that in the future, the incorporation of state-specific databases for measured drinking water concentrations from public water systems will add to the monitoring data that can be used to verify and compare with modeled drinking water concentrations. State-specific data should be evaluated in this evaluation. These data are important for risk communication. Texas also has a state law that requires notification of private domestic well owners in the vicinity of confirmed groundwater contamination. These groundwater contamination sites have included remediation sites with 1,1 DCA, measured and monitoring wells, although it is an infrequent contaminant included in the notices. Now I'm going to move on to groundwater contamination and exposure. So the EPA focused on evaluating surface water contamination from direct discharges of 1,1 DCA in section 3.3.3 and groundwater contamination from landfill leachate or biosolids containing 1,1 DCA in section 3.3.4. However, the EPA did not consider the possibility that 1,1 DCA could be stored in underground storage tanks as a solvent or chemical intermediate. If these tanks corrode or leak, the chemical could seep into the surrounding unconfined and combined aquifers to contaminate groundwater. This scenario is not impossible given that its isomer 1,2 DCA was historically used as a lead scavenger in leaded gasoline that is often stored in underground storage tanks. If 1,1 DCA is directly discharged into surface water or soil where mass exchange with air is active, this chemical is unlikely to accumulate due to its high volatility as it readily volatilizes into the air. However, if 1,1 DCA is released into groundwater and confined aquifers where mass exchange with air is limited, the chemical could potentially accumulate to high levels. To illustrate this contrast, a committee member ran a regional fate and exposure model called PROTEX, and peer-reviewed articles documenting this model will be provided in writing after the meeting. The results of the modeling show that if 1,1 DCA is 100% released into surface water, 89% of its steady state regional mass is distributed in air, and less than 3% of its steady state regional mass remains in surface water and groundwater. However, in contrast, if 1,1 DCA is 100% released into a confined aquifer, 98% of its steady state regional mass is found in the groundwater of the confined aquifer, and almost 0% is found in air or surface water. This is because the confined aquifer is not connected to the air and there's little chance for volatilization. In this situation, we may be able to find high levels of contamination in groundwater, which may pose risk to specific pest groups that rely on groundwater as their drinking water source. What's more, if groundwater discharges into surface water, we may also be able to find high levels of contamination in surface water. Therefore, it is more important to assess the case where 1,1 DCA is directly discharged into confined aquifers compared to surface water, which is done in the current version of the risk evaluation. It's important to evaluate the resulting human exposure through drinking water sourced from groundwater. Unfortunately, EPA did not account for the potential of direct leaks of 1,1 DCA into confined aquifers. For instance, when assessing contamination in groundwater, EPA considered groundwater contamination from landfill leachate containing 1,1 DCA. In Table 320, the EPA modeled 1,1 DCA concentrations in groundwater at various assumed leachate levels and various assumed loading rates. As shown in Table 320, even if EPA assumed almost unrealistic conditions, the model concentration in groundwater can only reach 0.917 micrograms per liter. This value is far below measured concentrations in groundwater samples, which are mostly above 1 microgram per liter and can reach as high as 1,900 micrograms per liter in some samples. As such, the EPA's modeling is not conservative as it should be. This modeling, the modeling results underestimate the actual risks of people who live close to underground storage tanks and rely on groundwater as the source of drinking water. It is recommended that EPA consider additional modeling of 1,1 DCA concentrations in groundwater when it is directly discharged into confined aquifers. Okay, now I'm going to move on to ambient air. So in section 3.3.1, that's the section discussing ambient air, monitoring, and modeling. So from US EPA's AMTIC website, One of the purposes of air monitoring data is to provide basic ground truthing for air quality models. Since approximately 30% of the facilities reporting 11 DCA releases to TRI, 7 out of the 23 facilities are in the state of Texas. It's important to note that Texas, along with EPA, has an extensive and robust stationary air monitoring network. In the in the years between 2015 and 2024, between 2015 and 2020, the same years as data were modeled, there were approximately 45 stationary ambient air monitors across the state of Texas measuring 11 DCA. 11 DCA ambient air data can be publicly downloaded from the Texas Air Monitoring Information Network that is available online. Over 99% of the samples analyzed for 11 DCA at approximately 45 sites across Texas between 2015 and 2020 are non-detect for 11 DCA. Some of the Texas air monitoring data includes 11 DCA data from as far back as 1994. The TCEQ's monitoring network is designed to measure pollutant concentrations for measuring regional air quality representative of areas frequented by the public. There's at least one EPA air monitor identified as the Westlake monitor measuring 11 DCA that is in the vicinity of the facilities in Lake Charles mentioned in this evaluation. It would be helpful to include an evaluation of the extensive available air monitoring data in this report. Even though, as stated in section 5.3.3.2.2, no general population non-cancer, cancer, or cancer inhalation risks are anticipated, the large amount of air monitoring data in Texas and other states is important to acknowledge and use for ground truthing in this evaluation. These and other air monitoring data better represent the general population's exposure to 11 DCA. In section 3.3.1.2, EPA modeled concentrations in ambient air and air deposition. EPA states that it developed methods to estimate air concentrations for inhalation exposures to a subset of the general population residing within 10,000 meters of a facility reporting releases of 11 DCA to TRI or NEI, but then applies this scenario to general population risks. The extensive air monitoring data should be discussed and used to evaluate general population exposure. If modeling is used to estimate air concentrations, the modeling assumptions used to characterize the subset of the general population should be accurately described and, as is, appear to better assess pest risks, not general population risks. This information is important for accurate risk communication. In section 2.2.2, which is the summary of fate and transport assessment, the volatility is a key characteristic for this chemical that impacts the distance from the releasing sources. The patterns in the movement of the chemical will likely be influenced by wind patterns, depending on the availability to the environment from the source. Also, the ambient air in the surrounding environment will change with season and weather, potentially affecting the movement of 11 DCA. See figure 2.1 for an excellent diagram of the potential distribution. In one of the figures, figure 3.18, it shows concentrations of 11 DCA in groundwater from US-based and international studies from 1984 to 2005. The graph shows the highest concentration in groundwater at 1,900 micrograms per liter from paper from Chen et al. 1995. However, this concentration was not found in the publication. The highest concentration in that publication was 10.84 micrograms per liter. The values in the table should be reviewed to ensure accuracy and recommend not using red as a color in this graph and others in the document. Recommend that EPA provide more information about how proximity to release sites is incorporated into the models and estimates of hazard and risk. The human health, pests, and other populations aspect is explained in detail. However, terrestrial and aquatic species are not explained as comprehensively, acknowledging the lack of data. Filling in data gaps is important, but would relate to additional uncertainty in the models. Recommend that EPA provides a discussion about the relationship of human health data potential risks to wildlife and as an indicator for adverse effects on ecosystems. And that concludes my summary, long summary. Now, I guess we can go to the other discussants.
Right. Yes, thank you for that. Very, very thorough and comprehensive. And let me ask Dr. Engel if he has anything to add.
Thank you. Nothing to add at this point.
Great. Dr. Hernandez? I thought I saw that he had joined us. Yes, Dr. Hernandez. We can't hear you. No. No. Well, no, I'm sorry, Dr. Hernandez, we still can't hear you. So maybe I'll ask, we'll ask Dr. Landis if he has something to add, and we'll come back to Dr. Hernandez.
No, that was very comprehensive and it caught all of my points. Thank you.
Great. Dr. Lee?
And that's very comprehensive. I don't have anything to add, but I just want to echo Dr. Jenkins mentioned. So she mentioned that one of the figures showed the highest concentration of the groundwater was not found in the publication. So since some of the comments are based on this number, so I suggest the EPA may have a quick check today and give us some feedback, some response during tomorrow morning's follow-up session. Thank you.
Okay, thanks, Dr. Lee. And I have a message from Dr. Hernandez that he did not have anything to add. And Dr. Ottinger isn't attending today, so I'll ask, is there anyone else on the committee who would like to make a comment about question 1? Okay, I am not seeing any hands, so I think we will move on to, oh, whoops, sorry. Okay, so does EPA have any clarifying questions about the committee's response to question 1?
Yes, I just wanted to ask Dr. Lee to clarify his comment on the computational comment for groundwater, I believe it was. Could you repeat that, Dr. Lee?
Okay, so my comment is in figure 3.18. So the highest concentration in groundwater was shown to be 1900 microgram per liter. That is from the paper Chen et al. 1995. Has a hero ID 659A73. But that concentration was not found in the publication. So if you go back to that publication, the highest concentration was only 10.84 microgram per liter. So that's why I was wondering whether you can have a quick check today and give us some feedback tomorrow. You're muted.
I see you nodding.
I was nodding my head.
Okay,
Yes,
yeah.
we will
Okay.
check and confirm.
Okay, thanks so much.
Okay, thank you.
Okay, great. Ali, am I right? We can move on to question 2A and have EPA read that in?
Yes, that's correct. We can move on to the next charge question.
Great, thanks.
Hello, this is Jennifer Brennan with US EPA, reading charge question 2A into the record. Limited empirical toxicity data are available for 1,1-dichloroethane in aquatic organisms for developing the environmental hazard values. See Appendix J1 of the draft risk evaluation. EPA selected 1,2-dichloropropane and 1,12-trichloroethane as analogs to read across environmental hazard to 1,1-dichloroethane. Please comment on the strengths and uncertainties related to the read-across approaches used for the selection of the analogs for aquatic organisms and environmental assessment as outlined in Appendix J1 of the draft risk evaluation. If appropriate, please provide additional methodologies that EPA could use to identify analogs for 1,1-dichloroethane for use in the ecological risk assessment.
Okay, thank you for that. And I will ask Dr. Landis to lead us off on the response to 2A.
Sure. One of our commenters' discussants was very clear in that this method seemed appropriate in a very conventional way. However, he talked also about, they talked about biosimilarity and other approaches, instead of looking just at the structure, but also looking at potential modes of action and other ways in which these chemicals would interact with some of the receptors and so on. So that's a point of view. Another aspect, and this is something that was commented on, is that questions 2A and 2B are very closely related in many ways. When you look at the A part of that question, it is pointed just directly at the structures of the chemicals and so on. However, if you look through the analysis that you go through when the read-through occurs, through the analysis of toxicity and so forth, agglomeration of the toxicity, and then how it's being used in the Web ICE program to get an SSD, that sets the performance criteria that these analogs need to meet. They need to be able to inform this other kinds of information. That's more than structural. It is also toxicological, what the data available are for those particular materials, how they would be used in a Web ICE derivation to derive a species sensitivity distribution. And that's the conundrum here, is that the analogs that were used seem to be appropriate. However, when you look at their ability to perform in the analysis, there are issues with the data sets, and also their suitability as an extrapolation tool into the Web ICE program. The issue is not so much structure, perhaps, but the fact that the data sets are very similar to what we'd expect in the mid-1980s when we had ASTM committees on toxicology, environmental toxicology and so forth, kind of setting those criteria. What you find in the reported information are information like low X and no X, and not really a dose response. So the criteria and so forth that were used to design those experiments for which we have data were not designed, those results were not designed for the current uses. That's an issue. The second thing is that there's a lot of extrapolation that goes on, and extrapolation's fine. The Web ICE is a useful extrapolation tool for taking information from a few species and a few chemicals and trying to extrapolate that to toxicity over very wide groups of organisms. The issue is that very few of these analogs were available, but when you look at the SSD, there are over 40 species, of which there are only data for 4 or 5, and the rest are generated, are estimated in order to generate that species sensitivity distribution. From that, an HC5 value is derived. And if you look carefully at the information available in that regression are derived from the overall modeling program, and they do not, I'm trying to put this, and they're not data. They're derived information, which can increase the uncertainty. You go through the rest of the notes I have. Oh, one of the issues is that the citation for the SSD is actually the citation for the species sensitivity distribution toolbox of EPA. That's not really a citation for the entire process. Make sure I've got everything else. Finally, it seems to be an issue in getting confidence intervals and that kind of information into the data analysis, or that it's being reported. All of that would be very useful. The last thing is that the species examined are limited to vertebrate and invertebrate for the species sensitive distribution, the vertebrate and invertebrate aquatic species, and there's very little information available for terrestrial species. And I think that's it.
Okay, thank you, Dr. Landis. And I will ask the associates. So if they have anything to add, so Dr. Engel.
Nothing to add.
Okay, and I think the other 2 associates are not in attendance today. Dr. Zhu is not here, right?
No, don't see him.
Yeah, okay. All right, so do other SAC members have comments for in response to question 2A? Okay, I am not seeing any hands. So I'll ask EPA, do you have any clarifying questions about the response?
This is Jennifer Brennan with EPA. No clarifying questions. Thank you.
Great. All right. So let us, excuse me, move on to question 2B and have EPA read that into the record.
This is Jennifer Brennan with US EPA, reading question 2B into the record. Please comment on the selection of 1,2-dichloropropane and 1,12-trichloroethane as analogs to support the 1,1-dichloroethane aquatic hazard database. Please also comment on the steps in the analysis, robustness, transparency of assumptions, and uncertainties of the conclusions, as well as the overall clarity with which the results are communicated.
Thank you for reading that in, and back to Dr. Landis.
So, and as I'm sure you noted, our comments for 2A and 2B are very closely related, and they hold for both questions.
Okay.
And just as my note, it's hard to address these things independently because the quality of the information and so forth is going to be related to the analysis tools. So it's not just the structural components. It's also, is the available information there in order to do that, in order to feed into the analysis which is going to occur. So these two things are not independent.
Right, thank you. And let me ask the associates. So, and that would be Dr. Engel. Do you have anything to add?
Nothing further, thank you.
Okay, and I'll ask the EPA folks if they have any clarifying questions for the response to 2B.
Jennifer Brennan, US EPA, no clarifying questions. Thank you.
Okay, great. I have a message from Dr. Cobb that he is on his way back to join us, but in the meantime, I think we will have EPA read-in question 3A.
Hi, this is Janet Burris from EPA. I will be reading in charge question 3A to C. The limited non-cancer empirical toxicity data are available for 1,1-dichloroethane for oral exposures, and ECRAD did not identify available data for dermal and inhalation exposures. The Agency for Toxic Substances and Disease Registry, ATSDR, completed a toxicological profile for 1,1-dichloroethane in August 2015. ATSDR 2015. EPA identified 1,2-dichloroethane as an analog for reading across to 1,1-dichloroethane non-cancer human health using the methodology found in section 5.2.1.3 of the draft risk evaluation. Charge question part A, 3A. Please comment on strengths and uncertainties related to the read-across approach and methodologies. In parentheses, Appendix J.2, used for the structural similarities, section 5.2.1.3.1, physical and chemical properties, section 5.2.1.3.2, metabolic similarities, section 5.2.1.3.3, and non-cancer toxicological similarities, sections 5.2.1.3.5 in the draft risk evaluation. If appropriate, please provide additional methodologies that EPA could use to identify analogs for 1,1-dichloroethane for use in the human health risk assessment.
Great, thank you for reading that in. And I get to recognize myself as lead discussant to start off the response to question 3A. High level summary. So we have some comments on clarifications on the metabolism assessment and some additional discussion of the uncertainties. So starting off with some general comments on the read-across methodology. Performing read-across on small molecules like 1,1-DCA is challenging because often very small changes in the molecule can result in large changes in the chemical features that might impact toxicity. Close attention, therefore, should be taken to identify analogs and evaluate them for similarity to the target chemical, considering physical chemical properties, reactivity, and metabolism. The assessment addresses many of these elements, and the assessors should be applauded for this effort. There are several key elements in the assessment where additional information and clarification are needed to increase confidence in the read across. So first, considering the metabolism assessment, As depicted in figure Appendix J1 and figure Appendix J2, in terms of metabolic similarities between 1,1-DCA and 1,2-DCA, both are directly reactive and both form chloroaldehydes, which can form persistent DNA crosslinks. And this is in, that reference there is OECD 2015. So that was a quote from the document. However, metabolism data for 1,1 and 1,2-DCA show differences in extent of metabolism, with the analog being more readily metabolized versus the target and forming quantitatively more reactive metabolites, including, importantly, formation of reactive chloroaldehyde and episulfonium ion, which can form adducts with macromolecules. The compounds display significantly different, different metabolism in both extent and generation of reactive metabolites. While both are readily absorbed, there is a significant difference in extent of metabolism. 1,1-DCA is poorly metabolized and rapidly excreted, predominantly unchanged, about 7% metabolized in rats after oral administration, while 1,2-DCA is extensively metabolized, about 60% in rats after oral administration. The reactive metabolites formed are also significantly different. A predominant metabolic pathway for 1,1-DCA involves the formation of 2 acyl chlorides, which have been, well, yeah, there's more details here, which have been proposed to react with cellular components, but also react with water to produce chloroacetic acid and acetic acid. A very minor aldehyde metabolite is also formed. The major metabolic pathway for 1,2-DCA involves the formation of a chloroaldehyde, which can react with cellular components. A second metabolic pathway involves formation of an episulfonium ion, which is proposed to be the predominant pathway forming adducts with DNA. While both compounds form chloroaldehydes, dichloroacetoaldehyde is formed from 1,1-DCA through a very minor pathway, while 1,2-DCA forms 2-chloroacetaldehyde through a more dominant metabolic pathway. In addition, 1,2-DCA forms the reactive episulfonium ion via direct conjugation with glutathione. These data show differences in extent of metabolism between the target and the analog, with the analog being more readily metabolized versus the target and forming quantitatively more reactive metabolites, including, importantly, formation of reactive chloroaldehyde and episulfonium ion, which can form adducts with macromolecules. The conclusion drawn in the document that there are metabolic similarities between the target 1,1-DCA and analog 1,2-DCA, and that both form reactive chloroaldehydes does not account for these important differences. However, if this more reactive analog with known toxicity data is acceptable as a worst case analog, then this approach could be used to support 1,1-DCA. In general, there is a lack of discussion of uncertainties. In section 5.2.7, weight of scientific evidence conclusions for human health hazard includes sparse mention of some, but important ones, including the inhalation study of Hoffman et al. 1971 of both 1,1 and 1,2-DCA in multiple species that indicates that 1,2-DCA is approximately 5 times more toxic than 1,1-DCA under those study conditions. This has important implications for the findings of the draft risk evaluation and must be acknowledged. A discussion of the potential uncertainties of read across in general should be developed and included in this evaluation. Over and or underestimates of risk could result. And we have references that we will include in our written comment. And that's the overall response for 3A. And so I'll put my chair's hat back on. I'm not sure if Dr. Cobb has joined us, but I'll ask our associates. So Allison Jenkins, do you have anything to add?
No, I don't. Thank you.
Great. And Dr. Rose, do you have anything to add?
No, no additional comments. Thank you.
And Dr. Stice, do you have anything to add?
Nothing to add. Thank you.
Okay, and other SAC members. So I see Dr. Graham has her hand up.
Yes, thank you, Cynthia Graham. I just want to reiterate that, you know, seeing that 1,2 DCA is so much more potent that I think potency should be taken into consideration within the risk evaluation. Thank you.
Okay, thanks, Dr. Graham. Anyone else from the committee want to add for question 3A? I'm not seeing any hands. Does EPA have any clarifying questions for the committee?
No, we do not.
Okay, great.
To read in charge question 3B.
Okay, thank you.
Okay. Read across analysis for human health risk assessment, charge question 3B. Please comment on the selection of 1,2-dichloroethane as the analog to support the 1,1-dichloroethane non-cancer hazard database. Please also comment on the steps in the analysis, robustness, transparency of assumptions, and uncertainties of the conclusions, as well as the overall clarity with which the results are communicated.
Hey, Mary and others, I made it back.
Well, welcome back, George. Do you want to recognize me to start responding to question 3B?
That's an interesting segue. So certainly, Dr. Fox, what does your subcommittee have to say about this, or your discussion group?
All right, thanks so much. And yes, again, welcome back. So for 3B, big picture summary. So the committee has some concerns about the read across methodology and the application of specific methods within. So there are comments about the using the AIM and the chem informatics modules. So according to section J.2, an analysis of other chlorinated solvents as potential analogs for read across data was conducted in accordance with the general principles for read across outlined in the Lizarraga et al. Paper 2019. This analysis considered structural similarities, physical chemical properties, metabolism, and toxicological similarities. And that's a quote from the document. In the publication by Lizarraga et al. 2019, an integrated approach was employed encompassing structure, physical chemical properties, toxicokinetics, and toxicodynamics to inform the identification and selection of analogs for quantitative read across and to determine the most suitable read across substance. Specifically, all these factors were evaluated for each potential analog to identify the most appropriate one. It appears that EPA did not adhere to this comprehensive procedure. Notably, at least one and likely more potentially suitable analogs were dismissed prematurely and without sufficient justification. Despite both 1,2-dichloroethane and 1,2,2-trichloroethane being classified as second pass analogs in AIM, and 1,1,2-trichloroethane exhibiting either a comparable similarity score in the OECD QSAR toolbox of 0.79 or higher in the HCD 0.78 versus 0.63 relative to 1,2 DCA. The EPA concluded in section J.2.1 structural similarity that 1,2-dichloroethane was identified as the best available candidate chemical to address the data gaps for 1,1-dichloroethane, based on additional lines of evidence and the fact that both are structurally similar reactive dichlorinated ethanes with identical molecular formulas and molecular weights. However, the term additional lines of evidence remains undefined in this context. It appears that the trichloro and other analogs were dismissed rather hastily without adequate justification. For a thorough evaluation, metabolic and toxicity similarity comparisons for the compound of interest and its closest analogs should have been conducted and detailed in the write-up. Such comparisons would allow for a proper assessment of consistency and concordance in target organs, adverse health effect, both non-cancer and cancer oral toxicity, and potential modes of toxic action. This analysis was not provided, leaving the early dismissal of the trichloro and other analogs unexplained and lacking sufficient evidence to demonstrate why 1,2-DCA is a more appropriate analog than the trichloro and other analogs. In summary, for this first part, section J.2 indicates that the EPA's analysis of chlorinated solvents as potential analogs was intended to follow the comprehensive methodology outlined in Lizarraga et al. 2019. However, the EPA's dismissal of at least one potentially suitable analog, particularly 1,1,2-trichloroethane, appears premature and inadequately justified, as the analysis lacked detailed comparisons of metabolic and toxicity similarities needed to validate the choice of 1,2-DCA over other analogs. And now some specific comments regarding the AIM software. One of the 4 software tools employed by the EPA to facilitate analog identification was the AIM software. According to the EPA, AIM first and second pass analog were compiled. However, the description provided does not clearly define what constitutes first and second pass analog, which diminishes the transparency regarding the process used to identify the most suitable structural analog. Additionally, the rationale behind the dismissal of certain first pass analogs is not addressed. Earlier this year in May, one committee member contacted EPA about issues with the AIM tool, as none of the links in the output were functional. A response from EPA is recorded that they are aware of the issue, but the committee member was informed that AIM is no longer supported and no updates are planned. And they recommended using the CompTox Genra tool. Given that AIM has not been updated or supported for 12 years, and EPA itself recommends using Genra, a tool also utilized in the selection process for the analog, in addition to AIM, the committee questions the appropriateness of relying on AIM. And now regarding the cheminformatics module. Another of the 4 software tools utilized for identifying analogs is the cheminformatics modules. According to information on the EPA's website, this tool is still under development, but is available for, quote, external stakeholders to use in order to provide feedback early in the development process prior to integration into production systems, such as the CompTox chemicals dashboard. If the information on EPA's website is accurate, this suggests that the tool remains in a developmental phase and may not yet be fully finalized and validated. This raises concerns about the appropriateness of relying on a tool that is still undergoing development. And so we have some recommendations that flow from this. We recommend applying the read-across procedure as detailed in the Lizarraga et al. 2019 paper, although there is a more recent publication Lizarraga et al. 2023, and if that is more appropriate, that should be used. We recommend providing a clear justification of the appropriateness of using AIM and the Chem Informatics modules. Utilize additional software tools to enhance the identification of potential analogs. Consider employing a category approach for the risk evaluation to minimize uncertainties. And then also a more thorough discussion of the potential uncertainties of the read across in general should be developed. Okay, that's what we have for 3B.
Great. Thank you very much for that, Dr. Fox. And now the associates are Ms. Jenkins.
No additional comments. Thank you.
And Dr. Rose.
Nothing more for me. Thanks.
And Dr. Stice.
No additional comments.
So for the rest of the committee, are there comments from those on the committee? So I will add a comment. This is George Cobb speaking. Regarding the availability of the model for the public use or public inspection, there was a panel convened for ORD related to models and developing new approach methods, and in that, related to new approach methods, the models that were being proposed there, one of the clear recommendations was that all of the models had to be publicly available so that people could actually see what was going on with those models and be able to trust that know what was being done within those models. So I concur with the comment that some work needs to be done with those models to get them available, or to perhaps work with additional or alternative kinds of programs. So that's my small comment.
This is Sabina Stice. I just would like to add that while public availability is important, it is also important to make sure that the tool used is fully validated.
Exactly. Dr. Chason.
A general comment about the model creations. In addition to making the models, quote, available, and certainly that has been shown that it is very possible for privately produced models to be made publicly available. But it's also important that as a component of what we would call publicly available, has to be a comprehensive description of the algorithms and the mathematics that are wired in to do the computations. For example, are there assumed distributions? If so, or how are the data being applied to any given parameter within an algorithm, as well as explicit presentation of the algorithms, any hardwired values for any of the parameters, etc. And that without that, making the model just quote publicly available, you still can't see what's going on behind the screen.
Point taken. Right. Other comments from the committee? All right. Let's see if there are clarifying questions from EPA regarding this feedback.
No, we do not have any clarifying questions.
Thank you. And now we can move on to charge question 3C.
And I will read that into the record.
Thank you.
Read across analysis for human health assessment, charge question 3C. Please include in your comments the extent to which the ATSDR 2015 toxicological profile for 1,1-dichloroethane provides information relevant to support the risk evaluation under TSCA. Thank you.
Thank you. So we have our same discussants. Dr. Fox is our lead.
Yes, thanks. So not much to say here, but the ATSDR 2015 toxicological profile supports the conclusion that there is a lack of hazard and dose response data for this chemical. The toxicological profile also makes mention of analogy to 1,2-DCA and to the class of chlorinated solvents in general. There does not appear to be any other specific information in the toxicological profile to support the draft risk evaluation. And we also have a few just editorial comments to make here. And that's it.
Okay, thank you. And Ms. Jenkins, any other
I don't have
comments?
any other. No, I don't. Thank you.
Dr. Rose?
No comments.
Dr. Stice?
Nothing to add.
Okay, so EPA, are there clarifying comments or clarifying questions?
This is Janet Burris from EPA. We do not have any clarifying questions on this one.
Okay, well, we're at a point that my schedule says lunch, but we're well ahead of the lunch schedule. So I think we should move into charge question 4. And if someone from EPA can read in charge question 4A, we can proceed.
Okay.
Thank you, Dr. Cobb. This is Ali Shawati with EPA, and I'll be reading charge question 4 into the record. Human health assessment, oral non-cancer acute, charge question 4A. As described in section 5.2.3 and section 5.2.6 of the draft risk evaluation, EC-RAD is proposing to rely on dose-related changes in kidney weights from Storer et al. 1984 for the acute oral point of departure, table 5-42, part A. Please comment on the study quality, study protocol, study conduct, and data interpretation of the Storer et al. 1984 4,1,2-dichloroethane. Please include in your comments information about the appropriateness of using the findings from Storer et al. 1984 for deriving an acute oral point of departure, POD, or extrapolating non-cancer risk to 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
Thank you for getting that into the record for us. And our lead discussant is Dr. Landis. Do we have Dr. Landis?
Oh, he's right here. He's just scrolling down. Now, I have a question about this. I may have the piece of paper I have says Stoner et al. And the paper the stuff I reviewed was the Storer material, 1984. Did I make an error in this? Do I need to go back and look at that? Did not find a Stoner paper.
I think the charge question says Storer.
Okay. Just wanted to make sure I have another sheet that says Stoner. Okay, fine. Good. I did not make a mistake. I just noticed that and going, All right. Question 4A. This is the feedback. And Mary may want to add something later. I went through and evaluated the Sawyer paper and found it very difficult to extract information that I would consider reliable for the process. As is typical at that period, the experiment was designed to use analysis of variance with multiple comparisons test to look at the exposure response. I understand that during the 1980s to mid-1990s, it's very difficult to compute these kinds of regressions that we now use. It was even difficult at that particular time to do multiple comparisons tests, of which there are many, and other ways of looking at particular information. So I went through and looked at experimental design and so forth. And a lot of this is impacted by how range finding and very typical kinds of tests were done at that time period. The concentrations are set to be multiples of each other, such as 500,000, 2,000, and so on. That makes it very difficult to derive a slope and to actually see where an exposure response is. The other thing, it limits the responses to saying the NOEL is a number related to the toxicity test. The NOEL is related to a number in the toxicity test. So you don't get that particular derivation. If the slope is steep, what happens is that you may not get that indication of where that break point is in that dose response curve. The other question that keeps arising is actually what statistical power is. The number of animals seems to be 5 in all of these items. It just seems to be a very challenging thing to derive the materials. So looking at that particular paper, it is very challenging to try to extract what the information should be and what should be used in order to derive the information for the point of departure. There's acute toxicity information in this, genotoxicity information in this, that's reported that may be useful, but I would prefer to have a complete, to get the actual information to derive a benchmark dose or some other thing that meets current standards before going to a point of derivation with this particular paper as the basis for that for this POD. That's it.
Thank you. Now we'll go to our associate discussants and Dr. Fox.
Right. So, well, I echo the concerns that, I mean, this study was sort of its time frame, which is in the mid 80s, right? But I did think that the data quality evaluation that the agency did as part of its systematic review was fair. Another thing to note about this study is that the kidney outcomes, which are the outcome that is being carried forward, was not the main focus of the study, but did seem to be, again, sort of appropriately evaluated within the article and presented. Yeah, so I'll add that to Wayne's comments.
Yeah, and Dr. Cobb, can I make just?
Oh, please.
That's a useful addition. And this is a question I continue to have in this thing. Evaluating data, papers, because I have another couple that we'll be looking at down the road in the context of its time as how it provides information to reduce uncertainty and to have an accuracy comparable to what's required and what's typical of regulation and studies now. Because we're looking 30 years into the past. And that's the context I keep coming up against. It's like a lot of this information and analogs is of its time. And that was a while ago. And that's a kind of uncertainty I don't see addressed very much when we go through later on and we're looking at all these documents. And this is for EPA too. How do we do the transferring that uncertainty now to the expectations of certainty in the current era? So that's an overall comment. And I think thanks.
Thank you. We have one more discussant, Dr. Kalushny.
Yulia Kalushny. Yes, I have multiple issues about this publication, as I found it that the study was, again, by that time, is very well controlled. There was a positive and negative controls. The sample size was maybe sufficient at best, not ideal. I had issue as to the endpoint, as nephrotoxicity seems to be not a known toxicity for the human. And so this kind of kidney-related toxicity is a big question. I'm still kind of uncomfortable with using 1,2-dichloroethane as an analog, as it's much more potent and toxic than 1,1-dichloroethane. And that's basically, it's oxidized, it's metabolized very differently, endpoints differently, and toxic endpoints different. So that's definitely kidney toxicity was a major outcome of this study, but how its relevance to human health effect is a big uncertainty in my mind. Thank you.
Thank you for that comment, and please do make sure that Dr. Landis gets that information if he doesn't already have it. I know there was not much time to pull some of these together, and people were working on multiple responses. So yeah, if that can just make sure all of that gets onto the record, that would be great. Okay, are there comments from others on the committee? All right, if we have none, EPA, do you have any clarifying questions regarding these comments?
Yes, Anna Loa, Senior Science Advisor, EPA. Yeah, a bit of a clarification, because the three respondents sort of gave different angles on the same study, which is totally fine, and we're looking forward to the report reflecting all of that. But we also heard a difference of view, which is also totally fine. We just want to make sure that that's what we're hearing, is that that there's some questioning of, because of the age of the study, and this is going to be true for nearly every study we talk about today, with maybe with the exception of the extended 1Gen and one or two others. The database for many of these organic solvents that EPA is working on now, it's not just these two, many of them have very old data. And we have to work with what we have to work with. And so the idea is to do the best that we can with that information. So I just want to make sure we answered the question that the program is proposed to use the study to assess acute effects for, so single day exposure to both the 1.1 and the 1.2. I heard a lot of uncertainties about the study and some questioning of the kidney effects, but I actually didn't hear an answer to the question. And if there's not a consensus on that answer, that's perfectly fine. We'd just like to know that there's not consensus and why that might be. But I didn't actually hear an answer to the question of using the study for the acute risk assessment.
I didn't read that specific, well, I guess the last part of it does say, comment on that derivation of the PODs. So, Dr. Landis, Dr. Fox, Dr. Kaluzny, do you have any response to that question?
So, Dr. Cobb, this is my recommendation that we have a great deal of information, and we also have I have all the reviews and stuff now, and why don't we have a joint, why don't we just get together and see what we want, how do we address that specific and very limited part of that paper, and to answer that question very specifically. That would be my suggestion. And does anyone else on the committee, on our little group of discussants, have a alternative or another path forward?
Hi, this is Mary Fox. So I'm on board with that plan. I think that that's a good plan, but I also would like to make it, I guess, a general comment, right? And a lot of my comments are about the uncertainties, but I want to make it clear that I want the agency to do its job, right? I'm not saying that we stop or anything like that, right? I think we need to grapple with the data set, right? And honestly acknowledge the uncertainties.
Okay, that's understood. That's also very helpful from my perspective. Dr. Kaluzny.
Yes, I'm agree with Dr. Landis. I think we should, as a group, have a discussion and to clarify our answer.
Okay, so yeah, we can arrange that either early in the mornings or at lunch breaks, or even after one of these meetings for you folks to have some time on the Zoom platform, or you can arrange that yourselves. It would maybe be helpful to have one more circle back to that sometime this week, just to have a very brief statement about that, if that's possible. But I think we've got enough here that it's not essential, but it will be helpful perhaps.
So, Dr. Cobb, I think what we will do is, that answer is very specific, and we can certainly just sit down and make sure we have a consistent answer.
Okay.
One of the issues in reviewing papers like this is that you can't help but read the entire paper. And you see the issues with the experimental design and so forth all the way through. And my experience tells me, if I'm having issues with one part of a paper, are there issues with other parts of it? So it's very hard to take it out of that overall context. So we can certainly do that. And Dr. I'll probably completely botch this, Kaluzny, I have her entire notes. I just didn't summarize them very well.
It's fine. I just made that statement because I know how much review everybody was doing and on multiple questions. So I just simply made the statement for that reason. But
Sure. And can I just perhaps have Allie make those arrangements? Because early in the morning for you is really dark for me.
maybe after the meeting one day,
Okay.
today or tomorrow could work.
All right. Thank you very much.
So we can circle back to Dr. Lowett.
Thank you. And if we can just put in a small request, thank you for doing that and following up. And we're going to key on all the questions to make sure that we're answering each part of the questions. Just if you keep in mind that the agency's under statutory deadlines and we're really hoping to finish this one fairly quickly. And so we'll be relying heavily on, as we wait for the report, the transcript and the notes that we take. So the extent to which this can be read out into the public record so that it appears in the transcript and all the public stakeholders know your answer, we'd really ask you to do that.
Yeah, thank you for that. Okay. Interestingly, after that particular comment, our next couple of charge questions, the committee was so strapped for time and personnel, we were unable to identify a lead for 4B and 4C. And at this point, if EPA can read in 4B, I think maybe Allie is going to read in a response that came from a couple of discussants.
Thank you, Dr. Cobb. This is Ali Shahati, EPA, and I'll be reading in charge question 4B into the record. Please also include comments on the selection of the BMR benchmark response selected, benchmark dose BMD analyses models used, and those selected. Please comment on clarity and completeness of the description of the BMD analysis. Thank you.
And Ellie, do you have that response?
Yes, I will turn it over to Mary Fox to read her individual response.
Mary, were you ready for that?
Okay, I'm ready.
Okay, I didn't want to put you on the spot because I didn't know if you were going to be ready with all the other things you were doing today.
That's okay. So I have comments about I think I don't have comments about the selection of the BMR, so I don't have comments on that first part. My general comment is mostly about the clarity, completeness of the BMD analysis, although some of it may relate back to the first part of the question. Okay. So in sections 1.1 and 1.2 of the draft risk evaluation supplemental information file on benchmark dose modeling, the agency neglects to acknowledge that the preferred approach to model selection includes consideration of the underlying biological process, and this is stated in the benchmark dose technical guidance. It is appropriate, as demonstrated in the dichloroethane assessment, that in the absence of that knowledge, statistical considerations such as model fitting, et cetera, guide the selection of the model. And that's what's reflected in the documents. The agency's benchmark dose modeling system has had Bayesian model averaging capabilities that may be useful for this assessment. However, I looked at the most recent version of the software and observed that the Bayesian model averaging may not be active in the current release of the benchmark dose modeling software. So this may be a situation similar to what we've heard about some of the read across models, that there are aspects of the benchmark dose modeling system that we might like to use, but that may not be available at this time. And and I had an editorial comment here as well, but that's it.
Thank you, Dr. Fox. Dr. Engel, did you have any comments?
Dr. Engel, are you there? I don't show him online.
All right, thank you.
So other committee members, are there comments about the BMR and BMD? Oh, what, Dr. Landon?
Yes, thanks. I also have a question related to what Mary just brought up. In doing the benchmark dose derivations, I know I've also seen the papers and the presentations of the group doing the model averaging using a Bayesian approach. And I don't see any note or mention of that in these not in the studies, but in the derivation of some of these things. And I want to strongly suggest that they be incorporated. It allows a much better mapping of the uncertainty with some of these calculations. And it seems to be a very promising and utilitarian approach. And I as well don't understand why it's not in the available materials online, but there are certain many publications and so forth that describe that process. That's it.
Oh, Dr. Graham?
Cynthia Graham speaking. I was not on this charge question, and due to having the many various charge questions and being lead on several, did not have the opportunity to read through this or read through the documentation. I would like to leave a placeholder here in the oral comments to actually review this and to add my comments at a later time.
So we will circle back to those things, and maybe if we can have an email exchange offline and find a time that would work, maybe later this week, if that's possible.
That would suffice. Thank you.
Okay, thank you. Other comments? All right. So with that information, we're going to provide more about the BMR BMD later this week. I guess we could go to EPA to see if there are questions, but I think this response maybe has lots of questions that we simply need to get a unified response for, or try to get a unified response for. So I'll turn it back over to EPA here.
Thank you, Dr. Cobb. Ali Shawad, EPA. At this time, we're going to wait until we have the additional comments so that we can, if any additional clarity is required, we can provide a request for clarity. We can provide that.
Makes sense. I just didn't want to cut you all short.
Okay. Thank you so much.
Dr. Cobb, you're muted.
I will go ahead and get charge question 4C read into the record. But I'll say that we didn't have comments from the discussants as of the time of the meeting. So we'll see if there are any comments for 4C. There just may or may not be. But let's get that into the record.
Thank you, Dr. Cobb. Ali Shohati, EPA, and I will be reading in charge question 4C into the record. Charge question 4C. If appropriate, please suggest alternative study or studies for use in deriving an acute oral point of departure, POD, for 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
All right, so our discussants were again Dr. Fox and Dr. Engel. I don't think there are additional comments, but I'll turn it to them. Dr. Fox?
Yeah, so I do not have another study to suggest, so I have nothing to add here.
Dr. Engel?
Nothing to add here either. This one's a real stretch for me too.
Okay, thank you. So we don't have any recommendations there from the discussants. Are there others on the committee who have comments related to this question? Okay, seeing none, I don't think there's any reason to get clarification there. I do want to take a moment, evidently, as I was going through the charge questions, when I did charge question 3C, I didn't ask if the full committee had any comments, and I apologize for that. So let's go back to 3C, which was about the ATSDR and the relevant information there. Were there comments from the committee on charge question 3C? Okay, I'm not seeing any, so I believe we are done with that. Now we're also done with charge question 4C. And although we are a little bit early, I think probably it's a good time to take a lunch break here. It's nearly noon Eastern. So maybe if we can come back in an hour, my clock would be an hour and 3 minutes at the top of the hour, wherever you are, the top of, not the 3-minute top of the hour, but the 63-minute top of the hour. And I thank everyone for attention, and we'll reconvene then.
Hi, George. It's Wendy.
Hello, Wendy.
How are you?
Good. I think we're on the record, so.
That's good. That's good.
But it's good to see you.
I just want to
Thanks for
say I'm here.
thanks for participating.
You're welcome.
Baylor's conspiring against me today.
What is?
Baylor, my outlook just went down. Oh wait, it's trying.
Oh.
Yeah, different systems keep crashing in different kind of platforms today. So I'm on my laptop right now. I might be able to get onto my computer, my regular one.
Never a dull day, right? Always
Oh God.
something.
Oh
Always
yes.
something.
With 1 minute to spare. Oh. Right. Welcome back to the Science Advisory Committee for Chemicals and our discussion of 1,1-dichloroethane. Before lunch, we were talking about exposure assessments and some of the hazard assessment aspects. And before we go on any further, I wanted to circle back and see if there were any comments from committee members related to the things that we talked about this morning. Okay. If not, the next thing on our docket, their questions are a little bit out of order because of the availability of individuals and timing. So our next charge question was going to be charge question number 11. And
sorry. Yeah. Allie, are you on?
Yes, I am.
Okay. Okay. We need to do the roll call.
Right. Oh, forgot the roll call of. So I'm sorry, Baylor tried to kick me off of all of my platforms just before this. I logged on like actually 10 seconds before this started up. So
Okay.
So I've got the roll here. Apologies. So Dr. Opti, are you here?
I'm still here for another 50 or so minutes.
All right, great. And then Dr. Ike?
I'm here.
I hope you're here. I think you're coming up
Yes,
soon.
I'm here.
Dr. Fong?
Yes, present.
All right. Dr. Fox? I see Mary.
Present.
Dr. Gentry?
I'm present.
All right. Dr. Graham?
I am here.
All right. And I missed everybody, not just you this time. Dr. Heiger Bernays?
Here.
Okay. Ms. Jenkins? C.
I'm here.
Allison? Dr. Lee? No, Dr. Lee. Let's see. Dr. Rubin, are you here?
I am.
Excellent. Thank you for joining us.
Pleasure.
Dr. Rumpler? Yes,
Here.
I see your name. Dr. Samuel? I see your icon. Dr. Samuel, are you there? We can come back. Mr. Wright?
I'm here.
All right. Dr. Engel?
Yes, I'm here.
Excellent. Dr. Hernandez? Dr. Kaluzny?
I'm here.
Dr. Landis?
Here.
Ms. Lynch?
I'm here.
Dr. Malberti?
Here. Here.
Dr. Rose?
Here.
Dr. Stice?
Present.
Right, and Dr. Zhu is probably still not with us. All right, let me back up and see. Victor, did Dr. Samuel get connected? And Dr. Hernandez. So I think we're ready to go. And
Cobb, I'm Lee.
oh, you made
Yeah,
it. Okay.
I was back.
All right, good. So now we can move on to charge question 11A. And if someone from the agency can read that in, then we'll have our discussants move forward with that. Do we have someone to read that?
Good afternoon. This is Mary Arentis, EPA. I wanted to respond to Dr. Lee's comment and question about figure 318 in the draft risk evaluation. If that was okay.
Sure, that's fine.
Okay. So we took a look at the reference that Dr. Lee highlighted, Chen et al. 1995, I believe. And in the figure, there is an order of magnitude, kind of an incorrect depiction of the order of magnitude of the concentration. So he's correct that it is not 10 to the 4th micrograms per liter. It is 1,000-fold less. However, the 1,900 that was referenced by Dr. Lee, that is associated with another study, the Sable et al. So that is, so we will go ahead and add that reference in the text, so to clarify and make sure that it's clear within the text.
Okay,
That
great.
answer Dr. Lee's question, I hope.
Thank you so much.
Yeah, I think that's good. That's good. And thank you for addressing that question. I do appreciate it.
Transition back to reading the question.
Okay, is that going to be you or someone else?
No, it will be someone else. I will get off the hot seat.
Good afternoon, everyone. This is Ali Shawati with EPA, and I'll be reading charge question 11 into the record. In 2015, OPPT received an OECD guideline 443 study entitled An Extended One-Generation Drinking Water Reproductive Toxicity Study of Ethylene Dichloride in Rats, Will Research 2015. This study was conducted to fulfill one of the requirements of an enforceable consent agreement under Section 4 of TSCA. During the agency's review of the data protocol for this study, the agency identified palatability and volatility as possible issues to be addressed. The 2024 data evaluation for the extended one-generation study is contained in pages 919 to 38 in the 1,1 dichloroethane draft data quality evaluation information for human health hazard animal toxicity supplemental file. Specifically, the draft data quality evaluation notes the following. Quotation, the study authors did note that concentration-dependent reductions in water intake throughout the study period were likely due to issues with palatability. This results in exposure levels that were generally below the target. Water intake was reduced by greater than 20% in the mid and high dose groups, and there were corresponding reductions in body weights. The authors noted that many of the effects observed, such as decreased body weights, organ weights, etc., stem from the reduced water intake and likely dehydration. Several other minor protocol deviations or errors were detailed. None of these were considered to have significant impact on the study results, end quote. Next slide, please. So, charge question 11A, please comment on how the data quality evaluation criteria were applied to evaluate the extended 1 generation study. Please include in your comments the extent to which OPPT has transparently and comprehensively documented the justification for characterizing the extended 1 generation study as uninformative. Please also include in your comments the extent to which this study is or is not useful for hazard characterization and identification. Thank you.
All right, thank you for getting that into the record for us. And our lead discussant is Dr. Lynch.
Thanks, Dr. Cobb. I'd like to preface that this was one of the last minute questions and one of my fellow discussants is not available to attend this meeting. So I anticipate there'll be some additional comments that come in the report, but let me give you the summary that I have. Okay, so EPA rated the extended 1 generation reproductive toxicity study by Will Research 2015 as uninformative based on largely a single concern, as noted in the charge question. This was primarily water consumption decreases that were associated with the palatability of water that contained 1,2-dichloroethane. This led to an overall uninformative ranking for the study based on a critically deficient ranking on metric 21 of the data quality evaluation framework, which addresses confounding variables in test design and procedures. The study is therefore mentioned only once in the risk evaluation on page 554 in a table in which it is simply cited and noted as being, quote, uninformative. However, based on the supplemental data quality evaluation document, nearly all of the 24 study evaluation metrics were rated as high quality, including all metrics in both the exposure and outcome assessment domains. No metrics were rated as low quality. The SACC discussants agreed there's concern that the body weight loss from palatability may have affected the study results. One reviewer noted that the loss of body weight has implications for other endocrine and reproductive functions. As mentioned in the Will study report, there were detectable changes in some of the reproductive hormones in treated groups, and so there was some uncertainty regarding the cause of those changes. The study report largely concluded that the palatability issues did not affect the study results, but there was some concern from at least one SACC member that observed effects were improperly discounted, and thus there was remaining uncertainty regarding the use of this study, even for hazard characterization. However, there was also recognition that in some cases, reduced water consumption may not confound reproductive assays and thus may still be valuable, particularly in determining no effect levels. Additionally, the SACC was concerned that this study, which otherwise was high quality, besides this single metric, was one of just a few studies evaluating this endpoint. And in contrast to those that were not excluded, it reported no significant treatment-related effects at the ingested doses. Moreover, the goal of this study and the consent order was to gather data for EPA that could be used with pharmacokinetic data to conduct route extrapolation from the oral to the inhalation route of exposure. SACC members expressed some concern that a test requested by and designed for an EPA's own program has been wholly excluded from the risk evaluation, even for the purposes of hazard identification. I would also like to draw EPA's attention to a published paper by Sweeney and Gargis from 2016, which I did not see cited anywhere in the risk evaluation. Consistent with the EPA consent decree request for the testing, Sweeney and Gargis analyzed the oral subchronic studies and the WIL study data, as well as the companion pharmacokinetic modeling that was conducted to perform route-to-route extrapolation of effect levels to inhalation concentrations. The authors acknowledged the palatability issues and reduced body weights in the reproductive study, but indicated that decreased body weight gain has also been observed in studies of 1,2-dichloropropane via other routes of exposure. For example, both the 90-day oral gavage study in rats and the Rao et al. 1980 and Payen et al. 1995 inhalation studies during gestation reported reduced maternal body weight or weight gain in the developmental studies. Moreover, Sweeney and Gargis analyzed decreased body weight as a potential point of departure for extrapolation to inhalation effect levels. One SAC member expressed some lack of clarity regarding the methodology that the WIL study authors used to calculate the actual ingested dose. The Sweeney and Gargis analysis did, however, account for lower water intake using the adjusted internal doses as the points of departure. Sweeney and Gargis reported that the inhalation equivalent no effect level associated with the extended one generation reproductive toxicity study was 62 ppm or 270 mg per meter cubed, which notably is higher than the predicted point of departure used by EPA in the dose response assessment for 1,2-dichloroethane or 1,1-dichloroethane. Overall, we recommend that EPA revisit the WIL study and consider whether the overall study rating should be changed, given our comments on the uninformative rating generally, which I'm going to talk about in a few minutes on the next charge question, and determine whether that rating is appropriate, particularly in light of the other strengths of the study. Regardless of whether EPA chooses to alter the overall quality evaluation rating for the WIL 2015 study or not, EPA should include a discussion of this study in the overall weight of evidence for reproductive and developmental hazards of 1,1-dichloroethane as a read across from 1,2-dichloroethane as well as 1,2-dichloroethane. Thanks.
All right, thank you. And Dr. Ottinger is not here, is that correct? Yes, Dr. Ottinger is not here. So I did want to clarify that we do have to get everything on the record this meeting, at least the concepts, if not the fine details. So we do need to make sure that we've got the gist of the comments captured for the report, because we can't add new concepts or new items here. We can add detail, but not necessarily new material. So with that, I'd like to open this up to the rest of the committee for additional comments. Dr. Graham.
I would just like to agree with the use as weight of evidence, even if it is considered uninformative after a review by EPA. I think using it in a weight of evidence is very important.
Okay, that's a good comment, and thank you for adding that. Are there others? Dr. Fox.
So, this sort of line of concern is running through many of the other questions. So I guess as a placeholder, I'll just say, I hope as a committee, we may be able to provide some guidance on, how we build in the right nuances in this kind of evaluation. So the studies can be used in the best way possible, right, to support the agency's work.
Dr. Cobb, you're muted.
I think we did see that there were uninformative studies that were used for bench for points of departure or other metrics for hazard assessments. So I think some of that nuanced approach should be good, but I think we do need to try to clarify some of that if we can this week. And that's kind of outside of my wheelhouse. So are there other comments? So I'd really like to thank Heather. I'd really like to thank you for stepping up and taking this at the last minute. This was a last minute ad, and you already had your plate full anyway. So I do appreciate you and Mary Ann for doing that. Let's go to the agency and see if there are questions from the agency.
Thank you, Dr. Cobb. This is Ali Shohati with EPA. At this time, we don't have a specific point of clarity that's necessary. However, we may circle back on this kind of point, as mentioned earlier, based on comments on the subsequent charge questions.
Yeah. I think that would be appropriate. All right, let's move to charge question 11B.
This is Ali.
Oh, excuse me, it's 12A. Sorry, 12A.
Yeah, okay, thank you. Ali Shohati with EPA. I'm going to be reading in charge question 12A record. EPA's OPPT is committed to continuous improvement of risk assessment methods and processes. The 2016 revisions to TSCA require the agency to use the best available science and to base decisions on the scientific weight of evidence. Charge question 12A. In light of your comments on questions 4 through 9 and 11, please describe whether the information rated uninformative in the above mentioned studies is appropriate for use in quantitative analysis and include suggestions on how OPPT might improve its approach to use the studies ranked as uninformative. Thank you.
Thank you for getting that onto the record for us. And Ms. Lynch is our lead discussant again.
Thank you, Dr. Cobb. For the uninformative studies mentioned in the question, the general consensus among the SAC members was that we agree that it's appropriate to exclude uninformative studies in some cases from the use for quantitative risk assessment, but that these studies should not be wholly excluded from the hazard identification process and assessment of the weight of evidence for the relevant health effects. However, for studies rated as less informative and generally considered of lower quality, the SAC members recommend that EPA include all studies in the qualitative weight of evidence evaluation. This is consistent with the 2021 draft protocol for systematic review in TSCA risk evaluations, which states, quote, studies rated as uninformative for dose response may be considered during hazard identification and in the weight of the scientific evidence. It also further states, quote, some aspects of uninformative studies may inform the hazard identification determination and or weight of scientific evidence for evaluating the body of literature for the specific discipline. We find that the draft risk evaluation as currently written does not in all cases sufficiently describe or justify that the study deficiencies are serious enough that they are not informative at all to the hazard assessment and weight of evidence. As an example that we just discussed, the Will study was not discussed at all in the draft risk evaluation. And the only summary of the fatal flaw, as it were, is a few sentences in the data quality evaluation supplemental materials on one of the very last pages. We recommend that at a minimum, EPA provide short summaries of the results of all studies identified for each specific health outcome, the identified methodological flaws, and also clearly state why the deficiencies in the study limit the study's use in the overall weight of the scientific evidence. To address the second part of this question, there are concerns regarding the way in which EPA is arriving at, quote, at uninformative ratings. Specifically, EPA can rate a study as uninformative based on any single quality metric which was deemed critically deficient. Rating studies as uninformative based on a single criterion is somewhat problematic and not generally the state of the science for systematic review. Further, some of the discussions in the risk evaluation suggest that an uninformative ranking may be applied in the case of a high quality study otherwise that provides no evidence of toxicity following chemical exposure. This is one of the concerns identified with the Will 2015 One Generation Reproductive Study, in which nearly all of the data quality metrics, other than the critically deficient metric, were rated as high. Note that our recommendations are consistent not only with the draft TSCA systematic review protocol, but also supported by the National Toxicology Program's Office of Health and Translation Systematic Review Framework. That's the OHAT framework, which has informed both the IRIS and the EPA OPPT systematic review processes. The OHAT framework explicitly discourages excluding a study from consideration based on a single metric, stating, quote, the tiering approach, and also recommends a tiering approach, stating, quote, the tiering approach outlined by OHAT favors inclusions of studies unless they are problematic in multiple key aspects of study quality, an approach that offsets concerns about potentially excluding studies based on a single measure, which could seriously limit the evidence base available for an evaluation, given the type of studies available in environmental health. One of the SAC members recommended EPA move away from using methods for data quality evaluation that use quantitative rating systems, i.e. scoring, and move towards more of the overall risk of bias in study quality rating based on weighting of domains and more qualitative metrics. We recognize that this has already been something that has happened over the course of the evolution of the systematic review method used by TSCA, in that initially there were weighting factors and more scoring in the 2018 evaluation framework for risk evaluations, and the 2021 protocol did remove at least the weighting metrics to move away from such quantitative scorings. Another SAC member indicated that the new 2021 systematic review protocol, while moving towards these qualitative rankings, inevitably still has to, in some way, sum or average the qualitative ratings on numerous individual metrics to reach an overall quality rating for that study. Therefore, attention should still be paid to certain domains that may be driving bias in the assessment and how likely they are to affect results. Overall, we recommend that EPA, again, provide short summaries of all relevant studies that they considered in a risk evaluation, including those ranked as uninformative. Moreover, EPA should reconsider whether it should rank a study as uninformative based on a single critically deficient metric. While ultimately best practices in systematic review and risk assessment are to avoid using low-quality studies for quantitative derivations, wholly excluding lower quality studies from hazard identification is not consistent with the best practices for systematic review. A potential path forward that could help streamline quality evaluation without fully excluding a study from consideration altogether would be to identify key metrics or domains during the early stages of the data quality evaluation and tier the data quality evaluation approach to efficiently assess studies based on these critical metrics of quality, without formally excluding any of the studies along the way. This would be similar to the tiered system that is provided as an option in the OHAT framework, but without specifically excluding any studies for hazard information. This would not require any changes to EPA's current framework in terms of metrics or qualitative ranking systems, but would rather help identify critical quality domains driving a study's informativeness for qualitative and quantitative assessment. Thank you.
Thank you for that readout. And we've got no specific members defined. So I'll go to the general committee for additional comments. Dr. Landis.
Thanks, Heather. I know I'm not on the committee, but I did go through those. The issue I have with this is that there's no clear definition of uncertainty or confidence that I can detect from this. which is moderate, slight, qualitative types of evaluations, pluses, minuses. I don't know how to add those together. And the definitions look, for uncertainty and so forth, look more common. And I just sent you a note with two citations that I use a lot to define uncertainty, more for the kind of ecological risk assessment I do, and they're pretty general terms for quantitatively dealing with the derivation of uncertainty and confidence and all those kinds of things. So that was my issue with how EPA addressed those questions. Thank you.
Good comments. Please make sure that Heather does get those. Are there other questions? Not questions, comments, excuse me, other comment. Okay, seeing none, I think you've got a pretty good handle on things here. And we can circle back to EPA now and see if there are clarifying questions.
Thank you, Dr. Cobb. Ali Shawati, EPA. At this time, we do not have any clarifying questions for the session.
All right. Thank you. So, interestingly, now we're starting on what is on our schedule, tomorrow's work. So, we're that far ahead. I guess I'll double check real quick with Dr. Ike that you are ready to proceed with that particular answer to the charge question.
I can be ready for charge question 5 now.
Okay.
Or 5A and 5B at least.
Okay. And while this was happening, I saw Mike Wright's hand go up. Mr. Wright, was that an error?
No, it wasn't, but I wanted it to go up with respect to 12A, and unfortunately my screen froze.
Do not worry.
So I wouldn't be able to.
Let's get through that.
So can I do that now?
Yes, please.
Okay. I just wanted to make the comment that that defining terms like uninformative and weight of the evidence, the more EPA can define those terms, the better it is. Not only for EPA, but for other agencies. And I'll give you one example using weight of the evidence. OSHA, in its hazard communication standard, used to say that one positive study that was well conducted was enough to establish carcinogenicity and to require a manufacturer to label a chemical as such. And then we got the globally harmonized system, which was a great step forward in almost every way, but it substituted weight of the evidence for the one positive study. And OSHA, for diplomatic reasons, because the US had adopted the globally harmonized system, essentially adopted that for its hazard communication standard. We did a little study a couple of years ago, and we looked at safety data sheets and found that with respect to things that were probable carcinogens, styrene, for example, safety data sheets were now all over the map. And interestingly enough, we discovered that the same company had a different had a different determination about carcinogenicity, mutagenicity, and teratogenicity in different countries. So in for example, one country, a particular chemical that was made by a particular manufacturer was called a carcinogen. In another country, it was not. In a third country, it might be a teratogen, but not a carcinogen. In a fourth country, it might be a mutagen, but not a carcinogen. And so the problem was that, they were all doing a weight of the evidence determination in their own way. And the more, and so what we're trying to do now is to get OSHA to basically define what they mean a lot better, and to say how they will evaluate a weight of the evidence determination. So the more we can attack these somewhat vague terms and really put some limits around them, I think the better off we'll be. And that's it.
Yeah, good points.
Thank you.
Good points. And now I see Ms. Lynch has her hand up.
I just wanted to respond and say thanks for that, Mike. I agree. And I think to just sort of outline to EPA and everyone else that I think that's a big part of systematic review, right? Is just the transparency and the understanding of how decisions are being reached, because ultimately there's always going to be some scientific judgment, you know, and there's going to be different approaches and policy goals for every agency that does any kind of hazard or risk assessment. And I think we all recognize that. So I think a lot of the comments we're giving is just to try to enhance transparency and understanding. And so even ultimately, if the results don't change, there's a clear understanding of why a study is, you know, in or out, and, you know, how EPA reached that decision. So thanks.
Good discussion. Dr. Hager-Bernays?
Hi, good afternoon. Can you hear me? Yes?
Yes.
Okay, great. So I want to agree. I do agree with what has been said previously. I apologize. I was not able to be here this morning, and this may be redundant to what's already been said, but I need to have it on the record in case it wasn't, right? Which is that, I'll be blunt, it's disappointing to see that EPA did not rely on well-accepted and transparent methods to identify and evaluate relevant studies for these chemicals. Being on the SAC and having been on the SAC, right, we know that EPA still has not implemented most of the recommendations made by this SAC, which has repeatedly at multiple meetings identified gaps or omissions in the systematic reviews and the processes, the definitions, and the transparency that is conducted. Yet EPA continues to rely on a draft systematic review protocol, or at least cites this protocol in this analysis. The SAC provided significant feedback to EPA on conducting these reviews that is transparent, identifies and evaluates existing literature, information, processes, definitions, and how those data can and should be used in line with the recommendations of the national academies. And the systematic review protocol for dichloroethane isn't transparent, and there is inadequate justification for inclusion and exclusion at both the hazard and the dose response levels. So, okay, I've said it.
Thank you, Dr. Hager-Bernays. And I had some similar thoughts about this matter. So I'm glad you mentioned that, because we did have an entire meeting on that a while back. So thank you for that. Other comments? Dr. Opti.
I just want to say that I echo what Dr. Hager-Bernays and you have said about the systematic review, and we had extensive discussion on it, and we are still waiting to see what happened with that. So I think some sort of explanation from the agency would be pretty good.
Agreed. Other comments from the committee? So since this circled back to question 12 and we revisited some of that, I go back to EPA briefly to see if there's any clarifying questions about what was said here.
Thank you, Dr. Cobb. This is Ali Shawati with EPA. At this time, we don't have any additional clarifying questions. So thank you for all the comments provided.
Yeah, thank you. So now we can, again, we're moving into tomorrow's work, but it's going to be charge question 5. And there's several parts to that. And I'm not sure how many we'll get through, but we will begin working on them. So if you can read that into the record, then we'll be good.
Thank you, Dr. Cobb. It's Ali Shawati with EPA, and I'll be reading charge question 5 into the record. Human health assessment, oral non-cancer, short-term, and chronic, charge question 5A through D. So as described in section 5.2.3 and section 5.2.6 of the draft risk evaluation, ECRAD is proposing to rely on the immunological effects identified in the 1,2-dichloroethane 14-day gavage study within Munson et al. 1982 for the oral non-cancer short-term and chronic points of departure, low L 4.89 milligrams per kilogram per day. EPA's conclusion about the Munson et al. 1982 drinking water study differ from the EPA's Office of Research and Development, ORD 2010 provisional peer-reviewed toxicity value, PPRTV, US EPA 2010, and the 2022 draft toxicological profile for ATSDR 2022. For example, the ORD PPRTV, page 33, provides a summary of Munson et al. 1982 and concluded the NOEL of this study will be the highest dose tested, 189 milligrams per kilogram per day. ATSDR 2022 on pages 166 through 168 did not select the Munson et al. 1982 study for POD derivation and provide an explanation of why the immunological findings were not selected for subchronic or chronic POD derivation. ATSDR defines a 14-day study as acute. That included scientific issues surrounding human relevance, dose selection, metabolism, and unknown mechanistic understanding. Next slide, please. ATSDR 2022, page 166 to 168, did not select the Munson et al. 1982 study for POD derivation and provide an explanation of why the immunological findings were not selected for subchronic or chronic POD derivation. I believe that's a ATSDR defined the 14-day study as acute, and that included scientific issues surrounding human relevance, dose selection, metabolism, unknown mechanistic understanding. The US EPA 2010 PPRTV relied on the drinking water study within the NTP 1991 study for the provisional reference dose, RFD. Similarly, ATSDR 2022 and their 2022 toxicological profile for 1,2-dichloroethane relied on the increase in kidney weights from the same drinking water study within the NTP 1991 study for their oral intermediate minimal risk level, MRL, for 1,2-dichloroethane, low L 58 milligram per kilogram per day. ECRAD evaluated the drinking water study from Munson et al. 1982 and NTP 1991 according to OPP systematic review process to be uninformative. Next slide. So charge question 5A. Please comment on the study quality of drinking water and gavage experiments in the same study protocol, study conduct, and study interpretation and data interpretation of the Munson et al. 1982 for 1,2-dichloroethane. Please include in your comments information about the appropriateness of using the findings from Munson et al. 1982 for deriving short-term and chronic PODs for the extrapolating non-cancer risk to 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
Thank you for getting that question onto the record. And our lead discussant for this is Dr. Ike.
We had a number of comments on this, so bear with me here. There's also a little bit of overlap with charge question 4. So we had concerns that ORD and ECRAD and ATSDR all appear to have some different opinions on this Munson et al. Study. And reviewers primarily agreed with the decision to not select the Munson et al. Study, as we also felt that there were issues relating to human relevance, dose selection, metabolism, and unknown mechanistic understanding. For example, the Munson et al. Study only focused on short-term exposures, which could be less relevant for humans if one of the primary routes of exposure would be occupational, which could suggest that this would be more long-term or chronic. Additionally, Munson et al. Notes that the subchronic 90-day exposure is believed to produce an adequate manifestation of chemical toxicity, with the exception of mutagenic and reproductive effects, which was a limitation as if there are reproductive effects, this would represent a critical population who could be uniquely susceptible to exposure. Additionally, 1,2-dichloroethane can cross the placental barrier and impact the fetus. Additionally, results from the Munson et al. Study only show effects of male rats, and while they mentioned that they tested female rats, these results were not shown. And it's also not clear if the dosage administered is human relevant. Results from the study also seem to focus on statistical significance and less on actual observed differences in effect size. For example, Munson et al. Notes that the data shown in figure 10 shows that neither any of the chemicals alter spleen cell response. However, when actually looking at the data in the figure, there does seem to be a clear dose response as compared to controls. Reviewers also had several concerns about incomplete reporting in overall study context, specifically for the LD50 gavage. Munson et al. Was rated low quality due to poor reporting of the acute study. For example, purity of the test substance, number of animals, and doses were not reported. For the short-term 14-day, Munson et al. Was rated high quality despite some concerns with reporting and dose spacing. Effects were well reported for this, including body weight, organ weights, and some mediated immune outcomes. For the 90-day drinking water study, Munson et al. Was rated uninformative due to reduced water consumption in the high dose groups. In selecting the 14-day study to base the oral non-cancer short-term and chronic POD, EPA should weigh and explain the related uncertainties and consideration, including the varying routes of exposure, the type of effects observed, and whether or not this effect would have longer-term or chronic consequences. And these considerations could then inform the adjustments and uncertainty factors that are reflected in the margin of exposure used for risk characterization. With regards to this statistical analysis, there were also concerns with limitations if the goal is to set concentrations for estimating the initiation of effects. In other words, that BMDL using regression methods to estimate a level equal to the present level, 10%, 20%, for example. And the selection of the NOAL is not equivalent, where the NOAL is dependent on the test doses, concentration selected by the investigator, and statistical power of the study design. In the Munson et al. Paper and the NTP paper for charge question 5B, reviewers could not find any indication of the statistical power of the analyses that were done using ANOVA. And for those that calculated the EC50s, they used appropriate regression and did indicate a confidence level. However, no indication below this level could be found. While reviewers understand that during the 1980s to the mid-1990s, computing regressions was much more challenging and time-consuming than it is now, it would have been possible to make these calculations using programs from various EPA and other laboratories using the desktop computers of that era. And the impact of designing experiments to estimate exposure response curves does appear to have an impact as well. For example, the concentrations are set to be multiples of each other, such as 500, 1,000, 2,000, 400, etc. And it can be challenging to capture the exposure response slope if it's very steep. And in this sense, the range of concentrations could go from essentially 0 to the maximum effect level in one interval. Another issue is related to the number of animals, which seems to be 5, and reviewers are not sure of the number of replicates per dose. And it also seems that the data plotted in the graphs of these papers and for charge question 5A, Munson et al. Are averages for the change over time. And in the size of the effects, the bar graphs, these are presented as means and standard deviation with just an asterisk to reflect statistical significance. As a general note, reviewers recommend that EPA revisit the ATSDR toxicological profile, which was finalized in July 2014, and update the draft accordingly. We also had some recommendations for multiple tools for the conduction of data analysis for exposure response data sets, and will include references for those in the final report.
Great. It's a very comprehensive response. Thank you for that. Let's see if the associates have additional comments. Dr. Engel?
The report was well done, so nothing further to add.
Thank you. Dr. Fox
Nothing to add.
and Dr. Landis. Okay. The remainder of the committee, are there additional comments from the committee? So seeing none, let's go to EPA and see if there are any clarifying questions for our discussants.
Thank you, Dr. Cobb. At this time, EPA does not have any additional comments or any clarification requests. Thank you.
All right, well, thank you. And now we can proceed to read in charge question 12B. No, 5B, excuse me.
5B.
Thank you, Dr. Cobb. This is Ali Shah with EPA, and I'll be reading charge question 5B into the record. Please comment on the study quality, study protocol and conduct, and data interpretation of the drinking water study within NTP 1991. Please include in your comments information about the appropriateness of using the findings from the drinking water study within NTP 1991 for deriving short-term chronic PODs, for extrapolating non-cancer risk to 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
Thank you for getting that into the record for us. Dr. Ike is our lead respondent again.
For charge question 5B, reviewers had similar concerns that ORD and ECRAD had different opinions on the NTP study. This NTP study received a high quality rating for cardiovascular, reproductive, renal, survival, and body weight outcomes. However, it was rated uninformative for endocrine, thyroid, and skin because of histopathology results for related organs that were not reported. Reviewers felt that it was appropriate to use the NTP study as compared to the Munson et al. Study for deriving short-term and chronic PODs. And if this NTP study is to be used to identify a POD for renal toxicity, as indicated in section 5.2.3.3.1, we felt that that data choice was supported by the data quality evaluation. Specific strengths of the NTP study are that they tested more target concentrations as compared to the Munson et al. Study. And we also felt that the data may be able to provide some better evidence that can be used to identify a POD. The NTP study also presented results for both male and female rats and presented all different outcomes. For example, survival, mean body weight, water consumption, that were both sex stratified, which can provide some possible evidence on sex differences when extrapolating to humans. And there was also information on a variety of other outcomes at different doses, which can be used to gather some insights on how target organs might be affected, which could also be relevant. Overall, relative to the Munson et al. Paper, reviewers felt that the results for the drinking water study in NTP were provided with substantially more detail. We had a number of editorial comments, which we'll outline in detail in the response. And then we also had similar comments related to the statistical analysis of the NTP study, and those were all captured in our response to charge question 5A.
All right, thank you for getting that onto the record for us. And let's see if we can hear from our other discussants and Dr. Engel again.
Nothing further.
Dr. Fox.
Nothing to add.
Dr. Landis. Seawine's
Nothing to add.
So Dr. Ike, you win the prize. You've got that summarized everyone's comments.
I'm doing my best.
Without additional comments. So that's very nice. So thank you. Let's go back to the agency to see if we have any, no, wait, we have to go to other discussants, other committee members first. So are there any other comments from the rest of the committee? Okay, now with no further comments, let's see if EPA has clarifying questions.
Dr. Cobb, I'm Anna Lowett, EPA Senior Science Advisor. So Dr. Ike, thank you for both of those. We're in an old building in a room with really bad acoustics, and you were reading really fast. I just want to make sure we heard some of the details. We interpreted from B that the panel prefers the NTP study for extrapolating the short and chronic PODs and not the Munson. Is that correct?
That is correct.
Thank you.
And that's a really important clarification. So yes. Okay, if there are no further clarifications, then we can move on to 5C, if someone will read that into the record for us.
Thank you, Dr. Cobb. This is Ali Shati, EPA, and I'll be reading charge question 5C into the record. Pending your comments on 4A and 4B, and if appropriate, please suggest any alternative study or studies, example, ATSJR 2015's toxicological profile for 1,1-dichloroethane, for use in deriving oral short-term and chronic PODs for 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
Thank you for getting that into the record for us. And now our lead discussant will be different. It'll be Dr. Fong.
Thank you very much, Dr. Cobb. On charge question 5C, we're not aware of any alternative studies that have already been conducted that could be used in serving oral short-term and chronic points of departure in this context. But we agree with the suggestion posted in the question that EPA should consider using the ATSDR 2015 toxicological profile for 1,1-dichloroethane for use in deriving oral short-term and chronic points of departure for these compounds. And we also would suggest reviewing the OECD 2004 screening information data set for high production volume chemicals 1,2-dichloroethane because the OECD SIT report compiles data on high production chemicals, including comprehensive toxicological and environmental fate data for 1,2-dichloroethane. This particular report contains information on both short-term and chronic exposure data, including key animal studies that assess oral, dermal, and inhalation toxicity, reproductive and developmental effects, and other hazard endpoints, which may be useful for deriving oral short-term and chronic points of departure for 1,1-dichloroethane. Thank you very much.
Thank you for that summary. And now let's move to our associate discussants. Dr. Ike.
I had nothing to add. Thank you.
And Dr. Engel.
Nothing to add.
Dr. Fox.
Nothing to add.
All right. What about the remainder of the committee? Any comments from the remainder of the committee? All right. EPA, do you have any questions for us?
This is Ali Shawatu, EPA. Currently, we do not have any questions that require any clarification. Thank you.
Oh, now we can move to the final part of charge question 5D.
Thank you, Dr. Cobb. Ali Shawatu, EPA, and I will be reading charge question 5D into the record. For charge question 5D, please comment on the extent to which there is potential for uncertainty associated with using short-term and subchronic studies for assessing chronic long-term exposure to 1,1-dichloroethane. Thank you.
All right, thank you. And Dr. Fong, again, is our lead discussant.
Thank you, Dr. Cobb. And when it comes to uncertainties, several members of the SAC members have already commented on about uncertainty. So let me just go specifically into the charge question. And of course, there's of course inevitable uncertainties associated with the use of short-term and subchronic studies for assessing chronic long-term exposures to 1,1-dichloroethane. The SAC members in our group thought that the better question here is it's how to best quantify the amount of uncertainty. And we suggest that the EPA work to try to answer this question, that is, how much uncertainty exists, rather than if there is uncertainty at all. So in this context, potential for uncertainty may arise from extrapolating data from animal studies to humans and the absence of epidemiological studies. And relatedly, we currently do not have a good sense of how constant exposure to these compounds would be over time and across various routes of exposure. So for example, the amount of exposure from occupational and industrial use versus amount of exposure in the general population, all of which can lead to uncertainty. There's also the potential for uncertainty stemming from the lack of consideration of cumulative effects. This could occur from not aggregating across both oral and inhalation exposure routes, but also not considering other routes of exposure, such as, dermal exposure as outlined in the background NTP 1991 study, or cumulative effects across both 1,1-dichloroethane and 1,2-dichloroethane, which the data indicate that have shared exposure sources. And uncertainty could also stem from the fact that we're largely relying on read across from 1,2-dichloroethane for 1,1-dichloroethane. And as indicated previously, these chemicals, while they're similar, there could be some nuanced differences, which could be explored if alternative studies were to be conducted and identified in response to charge question 5C. Another point that we want to make is that, on the use and reliance of short-term and subchronic studies to assess the potential for chronic long-term exposure to 1,1-dichloroethane. We just want to emphasize again that doing this introduces significant uncertainty, including the effect of duration of exposure. This is where short-term and subchronic studies may not capture the full spectrum of long-term effects that may result from chronic low-level exposure and delay effects that may not be noted in examining acute and early toxic responses. Also want to make note that we may need to adjust for the possibility of identifying a lower point of departure for chronic toxicity when extrapolating from a study of shorter duration. Also, another point we want to make is that the endpoints that are studied between short-term subchronic studies and long-term chronic studies may be different, and because chronic studies generally examine a broader range of health outcomes. And uncertainty is also introduced potentially because of mechanistic factors. So biological mechanisms leading to toxicity in chronic exposures might differ from those observed in short-term exposures. And also want to point to those differences between short-term subchronic studies and long-term chronic studies. Because short-term and subchronic studies, they tend to involve higher doses than the low doses that are used in chronic studies. And effects observed at high dose may not be manifested similarly at lower dose subchronic studies. Thank you very much.
Thank you for getting that response compiled for us and read into the record. Let's go to our associate discussants to see if there are further comments. Dr. Ike,
I had no further comments. Thank you.
Dr. Engel,
Nothing to add.
and Dr. Fox.
Nothing to add.
So the charge question 5 is summarized fully for the group. So congratulations. Let's go to the full committee and see if there are other comments from the committee. So I would simply like to add that I think that this is George Cobb. I think that extrapolating to chronic can be a problem. And the example I'm going to use is not human health, but it is a fish species. We were doing work years ago, and we had figured out something that was an EC10 for reproduction, and we used that concentration for a multi-gen study, and it turned out to be an LC70 by the time the fish got to be near reproductive age. And we had to completely retool our study because the scoping just didn't work, and the short-term subchronic effects just did not hold in a chronic fashion. So we always need to be careful trying to do those extrapolations. Oh, Dr. Landis.
So thanks, Dr. Cobb. That also brings to my mind how adverse outcome pathways might be useful to do this in that context, because I have seen similar things like with pesticides and so on. And that's just for at the individual level, the organism. And the environmental stuff here was fairly limited in this evaluation. We've also found that you get very interesting long-term population effects, and the incorporation of pretty straightforward population models can give you a variety of unexpected impacts. And my example here is all the Samanids, the Chinook and so forth, the very interesting life history strategies and stuff. So looking at fish populations, you can get very different. You can get cases where, a large percentage of them are fine population-wise in 10 years, but you'll also get a bifurcation, and some of them do not exist anymore just because of those kinds of events. So I think that's a caution that people need to hear more about. Yeah.
Yeah, thank you for that addition. Are there other comments from the committee? If not, let's go to EPA and see if you have any clarifying questions for us.
Thank you, Dr. Cobb and other SAC members. At this time, we don't have any additional clarification from the SAC. So thank you.
Okay. We are at a somewhat of perhaps a stuck point. Dr. Apte had to leave for the afternoon, and he was scheduled to give our next set of leads now for quite a while, and I'm not sure if Dr. Samuel, are you still here? to do question 8? Dr. Samuel?
Yes, I am here, and I could do question 8 if you like.
So are you prepared to do question 8? A?
Yes, I am.
Okay. So maybe give the EPA just a moment to reshuffle the deck or get to charge question 8A. And then I understand that the folks for charge question 6 are also ready, so we can move to them.
Do you want to do them first, the 6, and then we'll go back to 8?
If you're prepared for 8, unless you need more time, we can just do 8 now.
Okay, that's fine. Yeah, no problem.
Okay. So if EPA, if y'all can read in questions 8A, then Dr. Samuel will provide the response.
Okay, thank you, Dr. Cobb. This is Ali Shahati with EPA, and I'll be reading charge question 8 into the record. Thermal absorption, interpretation, and use of the new in vitro study. As described in section 5.1.1.1.5 of the draft risk evaluation, new data are available for an in vitro dermal absorption study using frozen human skin for conducted in accordance with OECD test guideline 428 and conditions of use COU information. The 1,1-dichloroethane test order, rates of penetration through human skin using a flow-through in vitro system study report, LabCorp, early development 2024. The draft risk evaluation for 1,1-dichloroethane supplemental information in vitro dermal absorption study analysis, US EPA 2024E, and draft risk evaluation for 1,1-dichloroethane supplemental information in vitro dermal absorption calculation sheet, US EPA 2024F, are available for review. As described in the study analysis, ECRAD has proposed to use a dermal absorption factor 0.3% in the oral to dermal route to route extrapolation. In the need COU exposure portion of the in vitro study, a total of 0.13% was recovered in the receptor fluid over 24 hours with an overall recovery of 58.42%. For the draft risk evaluation, ECRAD adjusted the dermal absorption factor to 0.3% to develop an upper bound value to account for mass recovery. And the other non-COU components of the study, example, diluted and isopropyl myristate, IPM, and 1,2-dichloroethane at various concentrations, where the recovery was greater than 80%. The dermal absorption ranged from less than 0.01% to 0.06%. The OECD 2022 guidance notes on dermal absorption studies, OECD 2022, states the following, quote, if recovery is less than 95%, but a robust explanation demonstrating the missing material would not have been or is very unlikely to have been absorbed, then the inclusion of the missing material might not be required, end quote. Similarly, the European Food Safety Authority guidance on dermal absorption, EFSA 2017, stated that, page 13, quote, losses that are considered to be from non-absorbed material will have no impact on the results, end quote. In the case of 1,1-dichloroethane, loss is expected to be due to volatility. The study authors did not conduct the recovery calculations, which were performed by ECRAD, because the, quote, the missing radioactivity was most likely due to loss of volatile test item at sampling. It is therefore considered that the losses would be associated with the non-absorbed fraction, and no correction for the losses has been made in the absorption value, page 331, end quote. With regard to overall recovery, EFSA 2017, page 13, states that if no clear conclusion can be drawn, only values from high recovery samples should be used to derive the absorption, and replicates from low recoveries should be excluded entirely, end quote. OECD 2022 on page 39 provides similar guidance. In the case of the 1,1-dichloroethane study, where the recovery was greater than 80%, the dermal absorption ranged from less than 0.01 to 0.06%. So charge question 8A, please comment on the selection and derivation of ECRAD 0.3% dermal absorption factor and its appropriateness for developing the dermal exposure and risk assessments for 1,1-dichloroethane, considering the range of replicate values for conditions of use testing, percent mass recovery, and data variability. If appropriate, please provide comments on an alternative dermal absorption factor. Thank you.
That was a long one. Thank you for getting that into the record for us. And now we'll turn to Dr. Samuel, who will provide the response.
Great. Thank you very much, Dr. Cobb. So the discussants for this question had quite a few comments, and I'm going to try to get through all of them and talk about the highlights. But there are a lot of different important points that the discussants feel need to be made on this particular charge question. So the first is just to summarize the objectives of this study, which was a study that was performed by LabCorp, involved 6 skin samples that were used to derive the data that were in Appendix 11.7. Overall, the discussants felt that the use of shifting to in vitro study analysis and utilizing the OECD Test Guideline 428 was timely and much appreciated for this particular analysis. And then with respect to the actual study itself, the objectives of the study, the LabCorp study, were to determine and compare the rates of absorption of 1,1-dichloroethane with, again, carbon labeling following in vitro dermal applications to excised human skin at multiple dose levels of 1%, 10%, 50%, and neat, using multiple potential solvents under finite and infinite dosing scenarios, and to determine the retention of radioactivity at the site of application. That was for the finite groups only. And just a moment here. It was noted that it was appropriate that human skin was used and helpful that human skin was used in the study. However, there's a question about whether the dose levels used in the study would reflect the potential real-life exposures given the very high volatility of 1,1-DCA. There was a concern about whether the best scientific methods were applied or the most appropriate dosing scenarios therefore were chosen. And so with respect to that question, dosing with 10 microliters per square centimeter of neat material was noted to be impractical. And it's more likely that the liquid material did not reach the tissue surface at all, meaning that the absorption occurred from vapor alone. When modeling a true quote unquote splash exposure to neat 1,1-DCA, the volume should have been increased or at least doubled. Otherwise, the tissue is exposed to vapor only and the study becomes uninformative. In those situations, when the liquid material reached the skin surface, it would not be expected to cover the entire tissue surface equally. Since the amount of liquid material actually applied, which would be 6.4 microliters to the skin, was not reliable and not expected to cover the entire 0.64 centimeters squared of skin surface during the study, the exposure surface was likely overestimated, which drove the dermal absorption factor down. And just a moment here. It is also not transparent why the existing chemicals or ECRAD has proposed to use a dermal absorption factor of 0.3% as the upper bound value in the oral to dermal root to root extrapolation. There are some explanations provided, for example, on page 241, indicating that, quote, the highest dermal absorption value reported in the 1,1 DCA OECD 428 study was 0.27% at 50% concentration in the 1,2 DCA as the COU vehicle. And then, end quote, in the evaluation of the LabCorp study, ECRAD used the OECD and European Food Safety Authority recommendations as they see fit. The mass recovery for the condition used for the factor derivation was only, however, in this one, 54%, which is outside of the OECD recovery standards, which are for volatile liquids, at least a recovery of 80% or greater, 80% to 120%. And therefore, this was not, did not appear that this was taken into consideration. And more important, the IPM, or isopropyl myristate, was able to retain the volatile test substance on the tissue surface and did get recovery of greater than 80%. And these data perhaps could be considered for determination of the dermal absorption factor. In addition, as per the OECD and EFSA, as I just noted, recommendations, a high level of recovery is essential to support low dermal absorption values. However, there was also some other discussion about whether there could be an explanation for the low recovery values. For example, there are some studies such as Cluxon et al. 2019, which has been noted by the discussants. And for example, this study notes that one aspect of working with volatile chemicals in such systems is that, quote, they may evaporate after the stock solution has been prepared, but before it is applied to the skin, end quote. And therefore, in these cases, could lead to apparent loss before the dosing solution is even applied to the skin, to the test skin. As a result, I think there are some significant questions about the recovery rates being low, particularly for the NEAT substance, which was the substance which was ultimately selected, or the factor that was identified for use in this particular risk assessment of 0.3%. One other thing I just wanted to note here, a couple things. Overall, the discussants also believe that the assumption of partial absorption of the unaccounted mass lacks sufficient justification and falls short of a robust explanation, and therefore the use of an adjusted fractional absorption of 0.3% may not be fully supported by the study that has been proposed, and particularly for the NEAT level of dosing. So I think in summary, the EPA it's recommended that they should more clearly explain the rationale and justification for choosing the 0.3% fractional absorption if that value is justified, and perhaps support that through more comparisons with other measurements. For example, there are some other measurements in the literature using flux-based approaches to determining the uptake for DCA, which does show in some situations the potential for substantial uptake. And those studies will be noted in the written record. And perhaps also considering the use of some of the other data from this study, if determined to be appropriate, where higher recovery rates were determined, and for non-NEAT substances applied to the skin. Okay, thank you very much. I think that summarizes the intent of the discussants.
Thank you for that thorough report out. That's very detailed. Let's hear from our other discussants. Dr. Graham.
Cynthia Graham, I have nothing further to add.
Thank you. Dr. Kaluzny.
This is Dr. Kaluzny. I have nothing to add. My comments were well incorporated. Thank you.
Thank you. Dr. Lee.
I don't have anything to add. Thank you.
Ms. Lynch.
Hi. Yes, I just have a couple things, and apologize if they were in there, Dr. Snobble. That was a lot summarized, so I may have spaced out for a second. But one thing that I wanted to bring up again that I think was mentioned either yesterday or earlier today was the NEAT condition of use. So assuming it's always undiluted, because the OES that EPA is looking at is manufacturing specifically 1,1-DCA as a NEAT substance as an intermediate. But I think there was someone who had mentioned yesterday, that if there's sweat on the skin, then it's not going to be a neat solution. And then I think also I brought this up, or I thought about this in context, and also I think there was some mention of this when Greg Masick was speaking yesterday, that there's also waste handling scenarios in some of these manufacturing OESs, and in the waste handling, evaluation of exposure, we wouldn't necessarily expect that to be neat either. So I think to the point of, can we be using the better recovery data for the non-neat occupational exposure scenarios, that might need to be reevaluated, because I think initially they were saying only neat is relevant, but perhaps that's not necessarily true in every single exposure case they've been looking at. And then the other thing I wanted to note was there was concerns, I think, or somewhere in the risk evaluation, it was assumed, because the study uses a vapor trap to catch and semi-occlude the vapors to try to help against, losing all of this substance to evaporation. But clearly they still had issues with that. But I had read and will provide some citations to Jennifer, or to Dr. Sommel about this. But sometimes I think even with those vapor pads with the volatile substances, sometimes depending on timing, it could potentially volatilize off that vapor trap as well. So that may be where some of the loss is, because in theory you're supposed to be catching the vapor, but maybe you're catching it and then it's disappearing again. So that was all I wanted to add. Thanks.
So, Dr. Rose?
I don't have anything more to add to the discussion. Thanks.
Thank you. So Dr. Kaluzny, I saw an icon pop up. Was that an applause, or was that a hand raise?
Both, I guess. But I'd like to thank Dr. Lynch. She remind me basically the comment which I want to make stress out based on yesterday discussion, that I guess in our comments we do need to stress necessity of using not only neat chemical for real life situation. I think actually I understand that EPA is looking for this advice as well, as to they initially they were advised to use neat material, but there is a scientific evidence to incorporate dilutions as well into addressing the best scenario of absorption. So I think we need to stress it out more in our comments. Thank you.
Yeah. Yes, thank you. And while we're having this discussion, it's just reminding me, I personally have particularly oily skin, and so as soon as anything like 1,1-dichloroethane touches me, it is definitely not 100% solution, because it is mixed up with the oils in my skin. So that's just a personal statement. I see Dr. Samuel has her hand up.
Yes, thank you. I just wanted to respond to Dr. Kaluzny and Dr. Lynch about this point with respect to the actual application of these data in the risk assessment for the occupational exposure scenarios. I do think that part is really important here, and it's hard to separate the discharge question and just the application of this particular study without addressing that. I was trying to do that, but I think it's really difficult to speak about one without the other. And I would strongly agree in the discussion and the helpful comments from Mr. Masick yesterday about the fact that we may not always have a neat solution, and whether the percent absorbed from the dosed solution is directly relevant to the risk assessment, and the occupational exposure scenario is, I think, very important here, and something that I'll definitely have some comments on that we've based on our discussion for the occupational exposure piece of this, because how this study then directly relates to what was actually in the real world exposed for these potential scenarios is important. So I completely agree with all the comments.
Thank you. Dr. Lee.
This is Lily speaking. So I just want to bring something to your attention. So because when I browse the data, I find the low coverage for many experimental groups when you use lead chemical, lead 11DAC for this experiment, but the recoveries are almost high for the rest of the group, especially when you use the mixture of 1,1 and 1,2 DCA. But in this assessment, the US EPA excludes the other things because they don't think they're using something relevant to the COU. So that's why the EPA rely on the adjustment for the recovery. But if you go with the experimental studies you don't limit yourself to the neat chemicals. And actually, if you can use the rest of data, you can use the data with the high recovery and you don't need the adjustment at all. And also, even if you do the adjustment for the high recovery groups, and you can still get a higher fraction absorbed, and maybe that would be more conservative.
Yes, thank you.
Yeah.
Okay. And let's see, any comments from the remainder of the committee? Okay, if not, we can circle back to EPA and make sure that if you have any questions for us.
This is Dr. Irwin. I have a question of clarification, two of them actually. So I just want to make sure that we heard it correctly from Dr. Samuel. Did you say that the area for the front cell was 6.4 square centimeters?
No, that was the microliters of volume of liquid material.
Okay, what was applied for NEAT was 0.64 microliter or 6.4 microliters. We thought we heard you say that.
Correct.
6.4 centimeters squared.
My apologies if that's what I inadvertently said. That was the microliters volume applied.
Okay, over what area then?
The area of the skin surface appeared to be 0.64 centimeters squared.
Okay, that was what was in the report. We just want to make sure that that was corrected. Okay. And also there was a comment that it was expected that the NEAT would completely vaporize before it hit the skin. So are you implying that we should do a vapor through skin analysis?
That's an interesting question. I think something that should be considered with respect to the evaluation, although I don't know how directly these data from this particular study would be to that scenario. That I think that could be a scenario that could be considered. However, I'm not sure that this particular study or this charge question would cover that question. But I think that could be something that could be taken up with charge question 10.
Thank you.
Yeah, and then we have Greg.
Okay.
Dr. Kaluzny.
Yes, Dr. Kaluzny, I wanted to just clarify the situation from my personal experience. indeed, 10 microliters per square centimeter end up with 6.4 microliters per 0.6 square transwell. And in acetation with highly volatile materials, it's evaporate as you dose, and 10 microliters really just covering. If you're very accurate, it just covers the tissue. So it's most probably it's exposed mostly to vapor or partial liquid. That means that's what it can drive the actual absorption down, because not the entire tissue surface is covered. And it is alternative approaches to expose to, there are ways to expose to highly volatile materials. They probably, if they're not added, they will be added in our comments, or vapor. It's also possible to do it, but it would be not exactly application as a splash, but at the same time it will, since it's highly volatile material. Basically you expose to some liquid, to some vapor. So depending of how you want to go, and considering if it's in this study, it was even the liquid applied to the skin ideal situation, and it was chamber, in a closed chamber, it's definitely exposure to vapor as well, and it's different physics of absorption. So it's just my comments, and we add it into the I'll update my comments as well. Thank you.
Okay, does that answer your questions, folks from EPA?
Yeah, hi, this is Greg Masick from EPA, and I'd also like to add a comment for this discussion. And we talked about the percent concentration for the different scenarios that were assessed for 1,1-dichloroethane, including our assumption that for each scenario, the chemical could be handled in neat form. I think that's a valid assumption, to assume neat, but at the same time, I appreciate the discussion that we've been having yesterday and today on possibilities of 1,1-DCAB present at dilute form, especially in the waste disposal scenario. So just appreciate comments from the committee in regard to that, and any information you might have on that. Thank you.
All right, thank you.
EPA members who also want to add comments, so I'll turn it over to them.
This is a hot topic. Anna Lowett, Senior Science Advisor. I'd just like to sort of get back to the practicalities of the assessment. This is an amazing conversation. I've learned so much. I'm really looking forward to some of those papers from Dr. Kaluznia on the vapor. But I'd like to sort of get back to this risk assessment and make sure we've got some clear guidance on moving forward. Just to remind everyone, we're in a statutory deadline and need to come to conclusion on what to do about this. And it may be that you need to go through the charge for the occupational to really come to conclusion, and that's fine. But so just for myself, not speaking to the team, for myself, what I'm hearing is that there's a lot of concern over using the value from the neat portion of the study because of the low recovery. That would leave us with either using the other portions of the study, the IPM or the mixture with the 1-2. Or Dr. Samo had mentioned that there were some citations around flux that the panel could provide. So I'd like some clarification on that, and if it's possible for for Dr. Samo to provide those citations to Ally quickly, so that we can look at those. I don't want to have to wait 2 months for the report to see those citations. If we could do that, that would be amazing. So that was my clarification.
So, Dr. Semmel, do you think those references could be provided in a few days?
Oh, absolutely. Yes, no problem.
Okay. So that's the answer to the one bigger question. And I can't speak for your group as to what you're saying about the various approaches for NEAT versus not NEAT, or if you have a strong preference. It sounded like you were saying consider the mixtures if they were a conservative approach, or am I putting words in your mouth?
I think the sort of maybe a bit of a conundrum is that, well, as long as the mixture data are considered to be relevant, that the recovery percentages of values were so much higher that those data are perhaps more reliable for situations in which they would be relevant. But that doesn't really resolve the issue of the NEAT, the question of the poor recoveries for the NEAT tests. And that's why the discussants in our group had the recommendation to consider perhaps the flux values, but that's then getting more into the risk assessment piece of this and the exposure piece. So I wasn't sure how much of that we should go into in this group versus commenting on just the applicability and quality of this particular study.
Okay, understand. Okay. So I think did that answer your question, Dr. Lloyd?
It did. I just want to make sure when we get circled back and the panel does do those occupational exposure questions, that we circle back to this issue so that we ensure there's resolution on it. So, but yes, thank you.
I think I'm hearing from Dr. Samuel that is part of that dialogue, will be part of that dialogue. So now I think we're finished with question 8, and we now in the mosaic of our charge questions, we'll be in charge question 6 now. And someone can read that into the record for us, please.
Hi, this is Jenna Purse from EPA, and I will be reading into the record charge question 6. Human health assessment, inhalation, non-cancer, acute, charge question 6A to C in introduction. As described in section 5.2.6 of the draft risk evaluation, appendix F in the draft human health hazard technical support document, or TSD, for 1,2 dichloroethane, and in the draft risk evaluation for 1,1 dichloroethane, supplemental information file, benchmark dose modeling, US EPA 2024C. BMD modeling was completed and used for several non-cancer points of departure: inhalation, Dow Chemical 2006. In these cases, the statistical benchmark concentration, lower confidence limit, DMCL, on the concentration at the benchmark concentration, EMC, used as the POD, is lower than the no observed adverse effect levels, NOELs, of each of the studies. See Table 5-43, Appendix F of the draft TSD technical support document. The US EPA 2012 benchmark dose technical guidance states, page 20, extrapolation sufficiently below the observable range may be too uncertain to reliably estimate the BMCs/BMCLs for the selected BMR, e.g. when all the dosed groups have near maximal responses. In such cases, BMD modeling is not recommended, and obtaining more data or using the NOAEL/lowest observed adverse effect level, LOEL approach, while recognizing the inabilities of that approach to resolve the data limitations may be warranted. So, charge question 6A. Please comment on the study quality, study protocol, study conduct, and data interpretation of the Dow Chemical 2006 for 1,2-dichloroethane. Please include in your comments information about the appropriateness of using the findings from Dow Chemical 2006 for deriving an acute inhalation point of departure for extrapolating non-cancer risk to 1,1-dichloroethane and 1,2-dichloroethane.
All right. Thank you for getting that into the record for us. And now we can turn to our discussants for the answers. And our lead is Dr. Graham.
I am Dr. Cynthia Graham, and the committee's response to charge question 6A in regards to study quality. The 2006 study conducted by the Dow Chemical Company entitled 1,2-dichloroethane acute inhalation toxicity with bronchial alveolar lavage and histopathology acute inhalation neurotoxicity study in rats was in compliance with good laboratory practice standards, the GLP, as published by US EPA, OECD, and the EC, which suggests that the study quality is acceptable and in line with TSCA expectations and requirements. Also added to the quality, the study conduct, data, protocol changes and revisions, and final reports were inspected by the Quality Assurance Unit of the Dow Chemical Company. In regards to the study protocol, the study protocol states that it followed EPA TSCA 799.9135, which is the acute toxicity with BAL and histopathology by inhalation, and 799.9620, acute neurotoxicity by inhalation, and OECD 424, neurotoxicity study in rodents. These test guidelines are appropriate and acceptable. Appropriate details were given for animal welfare, clinical observations, and determination of body weights, anatomic pathology, bronchial alveolar lavage analysis, histopathology, functional observational battery, and neuropathology endpoints. In addition, male and female rats were housed one per stainless steel cage with 12-hour light-dark photocycle, room air exchange, and feed and water ad libitum. All acceptable. As for the study conduct, the conduct of this study was well documented and in line with studies of similar nature with the following parameters. Whole body exposures occurred under dynamic airflow conditions. Rats were housed singly in cages within the exposure chambers. Test atmosphere concentrations were sampled from the chamber reference point of the chamber was determined approximately twice per hour. The rats for both the acute inhalation toxicity and acute neurotoxicity studies were exposed for a single 4-hour period to targeted chamber concentrations of 0, 200, 600, and 2,000 parts per million of ethylene dichloride. Since findings were seen in the histopathological endpoints, these endpoints were reevaluated through an additional single 4-hour exposure and a single 8-hour exposure at lower concentrations, as detailed by the guidelines of this study. And they were conducted to assess possible tissue-specific toxicity at lower exposure concentrations and longer exposure duration. It is not clear from the summary why the longer 8-hour duration was chosen for the lower concentration study, while the study report states that the follow-up 8-hour dosing was designed to fine-tune the nasal effects seen at higher concentrations and shorter exposure. Only the respiratory tract tissue and not other organ systems were investigated in the lower concentration, longer exposure study. As for data interpretation, the study concluded that histopathologic analysis to detect acute 1,2-dichloroethane induced injury demonstrated a NOEL of 50 parts per million for 8 hours. And this is an NOEL, so no observable effect level. Although there was a clear NOEL in the study, BMD modeling was conducted on the incidences using continuous equivalent concentrations and the default BMR for quantal data of 10% risk. And that's according to US EPA 3131 2012B. In sections 5.2.6 of the draft risk evaluation document for 11-DCA, the EPA authors state that for the inhalation route, all concentrations were adjusted for continuous 24-hour exposure to enable consistency in the HED and CSF as daily dose to enable comparison from different studies. However, using the continuous 24-hour-a-day exposure as an Appendix F to determine an acute POD is not explained and is questioned. In Table 5.43, it states that the adverse effect in the 8-hour acute study is degeneration with necrosis of the olfactory neuroepithelium, and this effect is neurological in nature. In the recent ATSDR 2024 assessment for 1,2-DCA, this same study effect was determined to be respiratory in nature. The rationale needed to consider the adverse effect as neurological versus local respiratory tract toxicity is needed. There was no evidence presented in the animal study that there were direct neurological consequences following the necrosis of the nasal epithelium. As for the appropriateness of using the findings from the DIAL study for deriving an acute inhalation POD for extrapolating non-cancer risk to 1,1-dichloroethane and 1,2-dichloroethane, the committee agrees that the DIAL study is appropriate to derive an acute POD for acute inhalation non-cancer risk to 1,2-dichloroethane. However, the use of an adjusted 24-hour exposure for an acute POD is not explained and questioned. As explained in the SAC comments on charge question 3, several of the models used to determine an appropriate analog were either not updated or supported for 12 years and is still in developmental phase, or the rationale used by EPA was not explained. So we are referring back to that charge question 3 as using this study as an analog, or using 1,2-dichloroethane as an analog. The public comments by the Vinyl Institute give a detailed example of the various models used by EPA to determine the use of 1,2-DCA as an analog for 1,1-DCA. Both empirical data and computational modeling suggest that 1,2-DCA is likely to be more toxic and or exert different toxicity than 1,1-DCA for several health hazard endpoints. According to the available regional screening levels, RSLs, 1,1-DCA was anticipated to be less potent than 1,2-DCA, and several other candidate analogs identified by EPA. And a figure is noted here, which will be in the written comments, which indicate that 1,2-DCA may not be an appropriate analog to use for human health hazard assessment of 1,1-DCA, particularly when considering potential potency of effect. So the recommendations are that an explanation is requested for using the continuous 24-hour-a-day exposure calculation to determine an acute POD. An explanation is needed on the determination that degeneration with necrosis of the olfactory neuroepithelium effect is neurological in nature, since there appears to be no evidence in the Dow 2006 study. EPA should review thoroughly the comments and suggestions submitted by Dominic DeCaria of the Vinyl Institute, and EPA should take into consideration the recommendations given in charge questions 3A. And there's an edit which will be added to the minutes on page 295, line 7864. And since this was actually suggested for tomorrow's response, I would like the other discussants to add anything that I was not able to add into this collated response.
So thank you for getting that detailed report out. And we are well ahead of schedule, which probably does mean that things are not as complete as in one summary as you might hope. So it sounded very good to me, but let's go to the other discussants and see what they may have to say. Is Dr. Merced Nieves with us?
Yes, I'm here. Thank you, Dr. Graham, for reading that very nice summary of our comments and working on it so much. I have nothing to add.
And Dr. Rose.
Yeah, Dr. Graham provided a good summary, so I don't have anything else to add.
All right. And do we have comments from others on the committee? Okay. Since there are not, and Dr. Graham, I have a question for you, or your group. It relates to the relative potencies, and I take your comment. I accept your comment as correct that we do not want to overly compound conservatisms, but if 1,2-dichloroethane is more potent, it would give us a conservative estimate, so it would be protective. And is your comment that it may be overprotective, or it just may be inappropriate altogether?
I feel that, and I think the rest of the group can add in, but I think it would be overprotective, and what EPA then does is add all these uncertainty factors, which lowers it even more. So I think they need to take that into consideration, the potencies, before they add in all of the additional uncertainty factors to lower that number.
Right, okay. And do I remember right, was that relative potency like it was a factor of 2? Is that right? Or it's okay. We don't have to answer that today. I'm just trying to keep things straight in my mind a little bit.
I don't know.
Okay. Are there further comments from the discussants? From the committee? Okay, we will circle back to EPA now to see if they're clarifying questions.
No, we do not have any additional.
All right, so thank you. And then maybe we can get question 6B into the record.
So I'm Janet Burris, and I will be reading into the record charge question 6B. Please also include comments on the selection of the BMR selected, DMC analysis used, and the clarity and completeness of the description of the DMC analysis. Thank you.
A short charge question. Sometimes these short ones take forever to get answered, but we'll see. Dr. Graham.
The committee's responses are that EPA recognizes that the data available is not well suited to carry out BMD modeling for some of the endpoints identified. In fact, adequate fit was not achieved in any of the cases. The committee agrees that BMD modeling should be carried out for females or males separately, the 4 and 8 hour studies, and for the combined males and females 4-hour acute exposure study. However, in each case, the models fail to predict a BMDL because of the high uncertainty at the lower end of the dose response curve, the 10% effect level. For the combined male and female study, even for the best fit model, the multi-stage 3, where the AIC is the lowest, the BMDL is still lower than the NOAEL. The NOAEL. According to EFSA guidance on BMD modeling, where model averaging is not possible because of the low fit quality, looking at models that have an area under the curve AIC within 2 units of the lowest AIC could also be considered in the analysis. There is only one additional model, the Weibull, within 2 units of the AIC of the multi-stage model. Based on EPA BMD modeling guidance, where there is greater uncertainty in the model fitting, it is warranted to obtain more data or use the NOAEL low-L approach. In this case, the use of the NOAEL of 71.3 milligrams per meter cubed would be warranted. It is questioned why EPA converted exposures to a 24-hour equivalent before carrying out the modeling to identify the acute POD. In doing so, the concentration at which the effect observed is artificially lowered. An example is the 4-hour acute inhalation for male rats. According to the Dow chemical report, the first effects were identified at 200 parts per million, or 810 milligram per meter cubed. And the table 4 from the Dow chemical report is offered, and it will be in the report. And while adjusting to a 24-hour exposure, the first effects of an acute exposure are reported to be at 132 milligrams per meter cubed. Adjusting an acute exposure from 4 hours to 24, especially with necrosis as an endpoint, requires careful consideration. Necrosis is a severe endpoint, and the relationship between exposure duration and effect can be complex. With regards to the extrapolation of the 4 or 8 hour to longer or shorter durations in brief, the understanding is that it can be done, but it depends on the study and the endpoint and the limit to be derived. Additionally, EPA should consider deriving different PODs for occupational and general populations, as exposure profiles are different for each one. In general, OELs are derived on the basis of an 8-hour or short-term exposure, or both. The recommendations are that the high uncertainty in the BMD model fitting warrants obtaining more data or the use of the NOEL low-L approach. In this case, the NOEL of 71.3 milligrams would be warranted. The second is that since necrosis is a severe endpoint and the relationship between exposure duration and effect is complex, EPA is requested to reconsider or explain the reasoning behind adjusting the acute exposure duration from 4 to 24 hours. And again, EPA should consider deriving PODs for occupational and general populations separately. And that's all I have right now.
All right. Thank you for getting that into the record, Dr. Graham. Let's hear from the associate discussants, Dr. Malberti.
Thank you, Dr. Graham. You summarized everything that we discussed in the very brief terms. I really appreciate it. I have nothing to add, but I do want to really highlight that difference between occupational and general exposures, because just the occupational is an intermittent, albeit long, intermittent exposure as opposed to the general population where we are assuming 24 hours exposure. So it's very important to really select the study design and the endpoint to be able to be relevant to the population or this scenario under study. Thank you for summarizing that, Dr. Graham.
Thank you. Dr. Rose.
No additional comments. Thanks, Dr. Graham.
All right. So let's circle back to EPA and see if they have clarifying questions for us.
Hello, this is Jennifer. We do not have any clarifying questions. Thank you.
All right. Well, now
This is Ali. Very quickly, does the committee have any questions on this on number 6B?
Thank you, Ali. It's getting late in the afternoon and my brain is starting to
no problem
keep things straight. So Dr. Landers.
Thank you. So I want to make sure I understood this. I remember reading this in the report and now I want to be clear about it. So one of the reasons for not taking the BMD approach is that the curve, the confidence interval, the lower end of that was below the NOEL. Is that correct?
Yes.
Yeah.
Yes. Is that a yes? I'm seeing a head move back.
Yes.
Okay.
Sorry. I thought I unmuted. Okay.
No, the heads on my computer are really small right now. So they're not supposed to be equivalent at all. As everyone here knows, a NOEL, NOEC, is a test concentration that was used. Whether or not it was significant has to do with the power of the test. And a test with very low power is very likely have a very different NOEL or NOEC because it can't see the difference. And that's why I have written that hypothesis testing is not always the best way to look at dose response. Well, the dose response curve is actually fitting a curve to the entire amount of information. And the fact that you have a confidence interval below the NOEC does not surprise me at all, given the power that these tests have from the data sets that I've been looking at in the other papers. I would expect the power to be very low. So they may not see effects at very low concentrations while the dose response curve is predicting that. So I don't see that being lower than the NOEL or NOEC is a reason for not using a curve fitting approach, given that all the other factors that go into making a good dose response curve are met. In fact, I would expect that given what I see from most toxicity tests. So I think using the NOEC is inappropriate in this case if the dose response curve fitting meets the usual criteria.
I would like to ask Dr. Malberti if she would like to respond.
So I will preface my response with stating that I can spell toxicology, but I'm not a toxicologist.
Well, I'm not either. not. I was never trained as a toxicologist. No.
Neither have I, right?
Yeah.
But my understanding, and again, I've done you can count with one hand how many BMDs I've done.
That's fine.
So with that, I think that I understand that with a BMD, your point of departure could be below the NOAC, but there's also the fact that the data, the dose response curve is not well fitted. And in fact, even EPA recognizes that this data set might not be appropriate for that, right? And so they have to resort to selecting the points of departure. And again, they did a very thorough evaluation of each one of the endpoints, and very, very few, if any, had a very good fitting curve. So it's not only that the BMD is giving you a point of departure well below the NOAL, but it's also that it's like it's not, you don't have the statistical reference for that.
Right. Let me just bring this out one more time. This is the problem, as I keep mentioning in my comments about the other things about not being able to see the data sets themselves, and all we're seeing are the summary statistics, is that what you like to have in a dose response curve is more concentrations than more replication, so you can get the tails. And in an ANOVA test, where the NOEL or NOEX seems so much higher than what you expect from the curve fitting, I suspect the statistical power is not very good, but I don't see power calculations in any of these things. So that makes me wary of having confidence in either approach. And so if the BMD is saying that it could be an effect in a very low concentration compared to the NOEL, then I go, was it designed appropriately to have enough statistical power to have a detection in that range? Is this a false negative? And EPA has people who do this. I know they do. And I think that would be a very important consideration, because this seems to be very important in the eventual risk analysis and the BMDL setting and so forth and so on. So that's I don't want to say a concern like I'm worried about it, but if I was evaluating that, these would be my questions 1, 2, 3, 4 that I would have to be able to make a better choice as to which one to use.
I will say that one of the things that I think it's more I would take more exception to is the fact that we're extrapolating a necrosis endpoint to a 24-hour exposure. That is the part that I think it's unrealistic that you would have that type of exposure and that type of endpoint, right? I don't know that they will relate one to the other, particularly with as endpoint, right? So again, if we are doing a study and it's like a chronic health endpoint, other, like, I don't know, weight, they had others, right? I can see how you can extrapolate from a short duration to a 24-hour, right? But a necrosis is something that is an irritant, something that is creating some cell damage directly. And again, I thought I misunderstood yesterday. I didn't raise my questions regarding using neurological endpoint, necrosis as a neurological endpoint, right? But again, so that such physical damage to the cells, having that extrapolation to 24 hours seems extreme, and I was questioning that.
Yeah.
Again, coming from a practitioner in the field where we have not seen evidence of, or I don't work in that field, but I haven't seen anything in the literature that has shown that those levels of exposures have caused any necrosis.
Dr. McBurdy, I wish that's a very important point. All the statistics in the world won't work if you're not actually measuring the thing you think you're measuring. And what it sounds like is that this study, this analysis, that the endpoint being used to give an indication of what's going on may not be the most reliable endpoint, which will increase your uncertainty and lower your statistical power.
Even more.
Even more. So I think that's a very important point. And I feel so much better that you brought that up, because that's also another thing. If your endpoint is not accurately representing the function that you're trying to do, that puts in additional uncertainty. And I would not be surprised to see that and a greater variability, and then lower statistical power, and then a dose response curve that may not have an adequate fit because you're not actually measuring accurately the response. So thank you very much. Yeah.
Okay. Yeah, and again, so the other point of suggesting different PODs for
Right.
different scenarios or different populations, even though it's not part of the charge question, I think this is very relevant to the type of discussion that we're having, because exactly that, right?
Yes, yes.
Thank you
Yes.
for explaining the comments.
No, absolutely. I think that's an important point. Thank you very much.
Dr. Rose, did you have anything additional you wanted to add to this conversation?
Actually, I think Sylvia addressed some of the points I was making around the uncertainty in the BMD analysis, and it wasn't just about the BMDL being lower than the NOAL, but the quality of the fit of all of the statistical models was low. And so that was the reason for the rationale around the choice of the NOAL in this case. But as she mentioned, I think probably what will have a bigger impact to the overall assessment and POD choice is the duration, extrapolation, correction.
Thank you.
Excellent. So this has been a good conversation, and I appreciate the fact that they're slightly different points of view, but everybody's realizing that the uncertainty is the thing that's really driving the conundrum, if you will. And I think whether a NOEL or BMD is chosen, we're probably going to get a reasonable answer, but it's which one is most appropriate given the data set that we have, and I appreciate that great discussion.
My pleasure.
I am sorry, my phone is trying to talk to me for some reason. So let's go back to EPA to see if there are any clarifying questions.
This is Janet Burris with EPA, and no, we do not have any clarifying questions.
Okay, thank you. So let's then move to question 6.
Well, very, very quickly, I think, is this a good time to take a 15-minute break, or do we want to move ahead?
Well,
Let
6C
me
is
pull
going to be,
Oh,
6C will be very short.
Okay.
So I think we can get that over within a few minutes.
Yeah, thank you, Allie. And if we can do that real quick, I think this may be it for the day, actually.
Okay, thank you.
So again, my name is Jennifer, as I work for EPA, and I'm going to be reading in charge question 6C. If appropriate, please suggest alternative study or studies for use in deriving an acute inhalation POD for 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
Thank you. And then Dr. Graham is our lead discussant again.
Yes, I'm Cynthia Graham. And we looked at the European Chemical Agency's chemical database, the website ECA and it showed 4 acute inhalation studies and 2 repeat dose studies by inhalation on 1,2-dichloroethane. And although these were not reviewed by the committee, we feel that EPA should actually look at them to possibly use in a weight of evidence approach. That was on 1,2-dichloroethane, but no studies were identified for 1,1-dichloroethane. The website for the ECA will be included in the minutes, where I could send them now.
So is that was fast?
That's it. Right.
You were right. That was fast. So let's go to the rest of the discussants, Dr. Malberti.
Nothing to add. Thank you.
And Dr. Rose.
Yeah, we weren't able to find any additional studies, so other than what Dr. Graham mentioned, so nothing more.
Okay, so that is the end of charge question 6C. And let's see what EPA has to say about questions, clarifying questions.
This is Janet Burris from EPA, and we do not have any clarifying questions for charge questions.
Okay, so thank you. At this point, I'd like to, I do want to take a 15-minute break. I think Allie was right. And Mary Fox, if you can hold on for just a second, I want to query you about path forward for the rest of the afternoon. So we can take a 15-minute break now. So Mary, are you okay to go this afternoon, or would you prefer to wait till tomorrow?
For question 7?
7.
Yeah, well, we've got good comments to make for 7A, and the group all contributed. We didn't get, I haven't gotten comments from everyone for 7B and C. I mean, I don't know if I will, but
okay.
I haven't. So, I mean, I don't know.
So what do you think about, do you feel comfortable doing 7A now? I mean, today?
Oh, yeah.
Okay, well, let's do that. If we can do 7A today, and then we may adjourn after 7A.
Okay.
Well,
that'll give us.
I have one more comment. Okay, if after 7A we still have time and Dr. Apti comes back, can we start on number 9 or not? Or is that just moving around the agenda too much?
If he comes back, we could go back to 9 and not do 7 today. But I don't, when is he going to be back?
4 p.m.
Oh.
And it's right now, after break, it will be, a little after 3:30.
Yeah, we could do that. We could certainly do that, but you might want to prepare Will for that 7A, then go back to 9 and the rest of the folks at EPA.
I think we're all under control in the logistics end, but you are being recorded and you are on YouTube right now. So you might want to have, if you're going to have this type of discussion, we can furnish a breakout room.
All right, I think we're good for now. Okay, so Mary, we'll go on to 7A.
Okay.
All right. All right, welcome back. I'd like to, first of all, we were talking about possibly going to question 7, but I just noticed, and thank you, Dr. Matten, for letting me know that Dr. Apte has returned, and he was leading charge question 9. And I was going to ask, are you ready to proceed with perhaps two of those sub questions today, Dr. Apte?
Well, I just responded back. I think we can do all of that together because the comments are so intertwined. It will be hard to split half, and it will be repetition again tomorrow of the rest. So I would rather just do it the whole block together.
Do you think we can do that in like an hour?
Today?
Yeah.
Yeah, I think we can do it all together today if you want. That's fine.
Okay.
And for clarification, when you say all together, do you mean 9A through 9D or 9A through
9A to
9G?
9D.
Okay, thank you.
9A to 9D, yeah. And then the rest is Robin Ann, I think. E to Dr. Gentry.
Okay, that sounds good. So, and I hope that EPA can get these questions up for us. Will can, and then the EPA can read them in. Dr. Samuel.
Oh, thank you. I'm sorry. I just had one clarification question. Does that mean we will definitely be doing number 10 tomorrow? Is that the plan? Because I do have to leave early today, and I just wanted to confirm.
If we start 9 today, that will be all that we end up doing today.
Okay, thank you very much.
Yeah, and to Dr. Fox, I apologize for putting you on the hot seat and then taking things away. Okay, so now if we can,
Dr. Cobb.
Yeah.
Okay, you're gonna go to 9 now?
Yeah, that's what I'm gonna ask, if EPA will go and read in charge question 9.
Oh, because I'm still waiting for some comments from one person, but we have enough, I think.
Okay, well,
let's go ahead and do it. I think
that person can comment
right directly
in session. Okay, let's go to charge question 9 then.
Hello, this is Janet Burris from EPA, and I'll be reading in charge question 9. The available rodent cancer studies for 1,1-dichloroethane have been determined to be inappropriate for deriving quantitative cancer risk estimates. EPA identified 1,2-dichloroethane as a proposed analog for reading across to 1,1-dichloroethane based on the methodology found in section 5.2.1.3 of the draft risk evaluation. The 1,1-dichloroethane draft risk evaluation includes a review of the cancer hazard data gaps identified for 1,1-dichloroethane, section 5.2.1.2.2, and outlines cancer hazard identification and evidence integration for 1,1-dichloroethane and 1,2-dichloroethane, section 5.2.5. Additional relevant information on 1,2-dichloroethane can be found in the draft technical support document. In the fall of 2023, ECRAD conducted an internal peer review of the available rodent cancer studies available for 1,1-dichloroethane and 1,2-dichloroethane by agency experts outside OPPT. While the internal peer reviewers and the ECRAD assessment team came to the same conclusion about the quality and utility of most of the rodent cancer studies, there was a differing scientific opinion, DSO, about the NTP 1978 mouse study with 1,2-dichloroethane. 3 documents are available for review by the SACC related to this internal peer review within EPA peer review of carcinogenicity studies for 1,1-dichloroethane and 1,2-dichloroethane 2024, available on EPA-HQ-OPPT-2024-0014. The original charge to the independent EPA reviewers, a review memo developed by those internal peer reviewers, and a response developed by the ECRAT assessment team.
This is Ali Munir. I just want to say that the docket number was not correct when it was read into the record. It is supposed to be 0114. So in its entirety, the docket number is EPA-HQ-OPPT-2024-0114. Thank you.
Thank you. Charge question 9A. Please comment on strengths and uncertainties related to the read-across methodology used for selection of the analog for the cancer assessment as outlined in section 5.2.1.3 and appendix J.2 of the draft risk evaluation. If appropriate, please provide additional methodologies which EPA could use to identify analogs for 1,1-dichloroethane. Thank you.
Thank you for reading that into the record for us. And Dr. Apte is our lead discussant for several of these in a row. So, Dr. Apte.
Thank you. This is Udayan Apte. So, in general, there is the use of 1,2-dichloroethane as an analog to assess the cancer hazard for 1,1-dichloroethane is scientifically defensible based on the structural and metabolic similarities between the chemicals. However, some SSC members have pointed out, and I'll be reading some of that here, is that use of 1,2-DCA as an analog is subject to certain uncertainties related to potential differences in the metabolic pathways and dose response relationship. As indicated by EPA and SSC members, both compounds are simple chlorinated alkenes and share similar physicochemical properties which support the use of 1,2-DCA as an analog. Both compounds are metabolized by similar enzymatic processes, primarily involving cytochrome P450 enzymes, with both compounds forming reactive electrophilic metabolites that can potentially bind to DNA and proteins, which can contribute to carcinogenic and other toxic effect. Also pointing out that importance of integrating appropriate uncertainty factors to account for any differences between the potency, as has been pointed out before, or pharmacokinetic or toxicokinetic differences between 1,1-DCA and 1,2-DCA. The strength and reliability of the analysis is limited by the availability of data for 1,1-DCA carcinogenicity, general lack of direct evidence for 1,1-DCA's carcinogenic potential introduces a high degree of uncertainty. Hold on one second. I'm going to go back. Yeah. And so overall, the use of 1,2-DCA for read across for 1,1-DCA, because of limited data availability on 1,1-DCA is justified. And I will stop here for this particular section of the question.
Right. Thank you for getting that into record, Dr. Apte. Our associate discussants, first, Dr. Gentry.
Yes, I would just add that I think we've heard from some of the other charge questions throughout the day, some of the issues with the read across approach and analysis and the additional data that need to be considered. So I just wanted to have that added to it. I think the answers we've heard from some of the other charge questions are important to incorporate into our response for this one as well.
Okay, duly noted. And Dr. Stice.
Just want to echo what Dr. Gentry said. I completely agree with her input, and that was what I was going to say as well.
Okay, thank you. From the other committee, are there additional comments from the committee? Seeing none, EPA, do you folks, Ms. Burris or anyone else have questions for us?
This is Janet Burris. No, we do not have any clarifying questions.
All right, well then we can move to 9B.
Cancer assessment charge question 9B. Please comment on the selection of 1,2-dichloroethane as the analog to support the 1,1-dichloroethane cancer hazard database. Please also comment on the steps in the analysis, robustness and uncertainties of the conclusions, and the clarity with which they are communicated. Thank you.
All right. Thank you for getting that into the record for us. Once again, we'll be hearing from Dr. Abt.
Okay, so this is very closely related to charge question 9A. So all we have to say here is that overall the use of 1,2-dichloroethane for read across for 1,1-DCA is because there is limited data is well justified. In this case, there seems to be a clear. It is clear that the available studies on 1,1-DC are not usable, and we will discuss that very soon here in the further charge questions for various reasons. And the best case scenario right now, based on the read across approaches, is to use 1,2-DCA, and that has been scientifically well justified. There has been some concern by at least one reviewer that there were other possible analogs that could have been used in addition to 1,2-DCA that have been omitted, and there is recommendations that have been put together here in a written report about some of these other chemicals that could be used, which were partly considered in the initial process of read across determination, and some of those data might be useful, is what the committee like to put it on record.
And now from the same associates, Dr. Gentry.
I guess I would add again, we've learned a lot from the other charge questions and some of the issues with the justification for using 1,2-DCA as the analog. And so I think all of those considerations need to be factored into the response for this charge question as well.
Yeah, and so this is George Cobb. I think that tying those together, I've made notes of that, would be important. And that would that, in your view, go to the steps or the robustness or all of that? I'm looking at the charge question as well.
Well, I think we've talked about all of it. I think throughout the charge questions earlier, where we talked about the read across approach and the issues with that, the uncertainties. So I think a lot of those comments regarding analysis, robustness, and uncertainties have been made as part of the responses to other charge questions.
Yeah, and actually those weren't supposed to be ahead of this one. This one was supposed to come out before that. So I take your point. And Dr. Rose, we can get to you just a second. Let's see about what Dr. Stice has to say.
Basically the same thing, everything that we stated at questions 3A and 3B apply to questions 9A and 9B. And we raise quite some concerns there. And I think we need to apply all of those here as well.
Okay, great. Thank you.
I can make that part of the written document, so I'll bring that in.
Yeah. Thanks for making that tie. All right. Now we can go to the full committee, and Dr. Rose, you beat me to the punch. You had your hand raised before I even got there.
Yeah, no, yeah. I guess I was super eager. I guess I just wanted to make the point, having responded to charge question 3A, I guess 3A, B, and C, that yeah, the same read across approach was employed for cancer and non-cancer up to the point of the toxicological evaluation of the qualitative toxicological evaluation of the data. So I think a lot of the information that we provided to our response to 3A will be applicable here.
Excellent. That's a really good comment. And I think that probably would go to the steps in the analysis, because that's one of the parts of the chart. So that's really good information. Other committee members, comments from others? Okay. Dr. Apte, do you think you have what you need for these two so far?
Yes.
All right. Well, EPA, do you have any clarifying questions for us on this response?
We do have one clarifying question on this charge question and the discussion. It was mentioned that one member or certain members have suggested that other possible analogs were omitted from the analysis, and we wanted to clarify what those possible analogs were.
I'll have to dig through this large report, but we will have that specific information in the written report. And if the particular.
So, Dr. Apte, it looks like Dr. Stice was going to.
Yes, I was one of those people who provided those comments regarding ignoring some potential analogs. Those are basically.
Oh no, Dr. Stice froze.
It froze, yeah. I think, hold on 1 second, I can dig that up real quick.
I think it was some of the analogs that were in the tables, but were excluded over time.
And then she had concerns about that. And then she had clear comments about what those are. Give me 1 second. Since there are comments for 3A, I did not directly include them, but I have them here.
So.
Yeah, so hi, Dr. Fox here, Mary Fox. So I think the one, at least one example that Dr. Stice had written into our previous comments was 1,1,2 trichloroethane.
Yeah. In her comment, she has said that in summary section J2 indicates that EPA's analysis of chlorinated solvents as a potential analog was intended to follow comprehensive methodology outlined by Lazaraga et al. 2019, which includes evaluating structural, physicochemical, metabolic, and toxicological similarities. However, the EPA's dismissal of at least one more potentially suitable analog, particularly 1,1,2 trichloroethane, appears premature and inadequately justified, as the analysis lacked the detailed comparison of metabolic and toxicity similarities needed to validate the choice of 1,2 DCA over the other analogs.
And I think that came in, Mary, I think you got that in earlier in the day, right?
Right.
So Janet, does that, Ms. Burris, does that answer your question?
For my question, thank you, George.
All right. Did you have other questions, or was it just the one?
Just the one. So.
All right. Well, let us go.
Apologies. It looks like I lost internet at the very best
Yes.
possible time. So basically, I'm not
so
sure
we-
how much you heard.
Some of your colleagues just read your comments in from question 3A. So I think we've got those now captured.
Okay, yes. So basically, I just think all the potential analogs need to be put through that procedure, that EPA reference, to show us that they indeed selected the best possible analog. And the other thing is to consider maybe a category approach instead of an analog approach. That's all.
Thank you. Thank you. So now I think we've got all the questions from EPA out of the way. And now if we can go to 9C.
This is Janet Burris from EPA, and I will be reading into the record charge question 9C. Please comment on EPA's preliminary conclusion that the NTP 1978 mouse and rat cancer studies for 1,1-dichloroethane are not appropriate for use to quantitative risk assessment. Please also comment on the extent to which the 1,1-dichloroethane rat and mouse studies are or are not useful qualitatively in hazard identification and characterization. Thank you.
All right. Thank you for getting that into the record. And we once again return to Dr. Apte.
So in this case, committee had a consensus that excluding the 1,1 DCA NTP 1978 study from consideration of dose response is appropriate, given the high rate of both pneumonia and the mortality across all doses in the study. Survival in this study was so low that all rats in all groups, that while this study that has excluded this study from consideration. However, there is also a consensus that this study still could be discussed in hazard identification. The low confidence in the study means that it should be given very little weight in consideration of carcinogenic hazard. For mice, there is still some pneumonia seen in these studies, but it was limited to the exposed groups and not the controls, which could bias away from the null, that is, could yield a higher apparent effect than in reality. The survival in female mice was high enough for sufficient statistical analysis. Therefore, this study can be used with some caution in hazard identification, but should not be used at all for dose response assessment. According to the EPA's guidance on systematic review, uninformative studies can still be used for hazard identification. So this fits the bill. And so that's the general consensus of all the members.
Okay. Well, thank you for getting that into the record for us, Dr. Apte. And then let's go to our associates and Dr. Gentry again.
I don't have anything to add. Oh,
Did I read the wrong one? No, I just read the wrong order.
oh, that's fine.
Yeah.
But I don't have anything to add. He captured our summary.
Excellent. Thank you. Sorry for interrupting you. Dr. Fong.
Nothing to add. Thank you.
You're on mute, Dr. Cobb.
Oh, Ms. Lynch.
I have nothing else to add either. You got it all.
All right. So we've gone through that. Does EPA have any clarifying questions for Part C?
No, we do not have any clarifying questions for Part C.
All right. Well, let's move into.
Well, before you do that, we haven't opened up the question to the committee. So does the committee have any questions on 9C?
You're correct. Thank you, Alan. Any comments from the committee? So Now we can move to 9D.
My name is Janet Burris. I work for EPA, and I'll be reading into the record charge question 9B. Please comment on the strengths and uncertainties and use of the Nagano et al. 2006 study with 1,2-dichloroethane to develop an inhalation unit risk for inhalation cancer assessment of 1,1-dichloroethane and 1,2-dichloroethane. Thank you.
All right. Thanks for getting that into the record for us. And again, Dr. Apte.
All right, so there is again a consensus seems to be building up on this question. The Nagano et al. Study is a relatively well-conducted study. It is likely that at least some of the tumors reported in this study are treatment-related, particularly in the rats where the tumors are in the high-dose group well exceeded those of the historical controls. But there are certain remaining questions about the dose-response relationships of the other tumor types based on visual observations of the tumor counts at each dose and the concerns with PTOS test for both species, but particularly for rats given mortality was low. This concern is due to the fact that PTOS test, the paper is Pito et al. 1980, is typically used for analyzing data of a tumor that is considered non-lethal to a subset of animals and lethal to the rest of the animals, and also requires an assessor to determine whether the tumor caused the animal's death. The analysis will become biased if the assumption or information on tumor lethality and the cause of death is not valid or accurate. This has been substantiated in a paper by Dinsey et al. 1994. Although a different trend test may find the same answer, it would be helpful if the agency for the agency to obtain the raw individual animal data and rerun trend test via the poly-3 method or other trend tests to confirm dose-response relationship. It is also notable that there are two other studies that show no evidence of cancer at exposures assessed. These are Maltoni et al. And Shiver et al. Papers. The inhalation study by Maltoni was ranked as uninformative in the risk evaluation. The Shiver et al. Study was ranked as high quality. However, there is no discussion of Maltoni study outside of the tables in the risk evaluation process. It appears that the hazard identification weight of evidence evaluation for carcinogenicity is incomplete because of that. Uninformative studies are not supposed to be used for dose response according to EPA's systematic review protocol, but they should not wholly be excluded and can be used for hazard identification. Finally, most importantly, there are also some concerns about the read-across carcinogenicity potential of 1,2-DCA and 1,1-DCA, which we have already discussed in previous charge questions. Thank you.
All right, thank you for that thorough response. And then let's go to the associates. And first is Dr. Fong.
No additional comments. Thank you very much.
And all right, thank you. And then Dr. Gentry.
No additional comments from me either.
And Ms. Lynch.
No additional comments either.
Great, thank you. From the rest of the committee, are there other comments from the rest of the committee? Okay, seeing none. EPA, do we have any clarifying questions from you?
EPA does not have any clarifying questions concerning question 9E.
Okay, thank you. And I'm sorry to keep saying EPA. I'm never sure who's going to be talking because it's a blank screen. So I apologize for being so impersonal there.
No problem. We are using the same chair and switching.
Yeah.
We're
So,
playing
okay. And I think that this is probably where we're going to stop for the day as far as charge questions, but I do want to circle back and see if anyone on the committee has a comment or something that we are going to need to address in future times. We're nearly a full day ahead of schedule here. So I think it's probably time for a break. There's some work that needs to be done in drafting some questions and improving them for tomorrow. But let's circle back to the committee. Are there topics or issues that have not been discussed or that have come to your mind as we've been going through these questions that need to come for discussion? Okay. Well, we will have that same question when we start in the morning, just to make sure. And then I do have one topic, and I'm going to apologize for not being here early enough in the day. I may have missed this if it was discussed. And it's more of a questions to start with for folks that were in charge question 1. In the past, the committee has suggested that EPA needs to be careful about slicing and dicing the exposure scenarios in ways that you lose the aggregate exposure by not considering all the different exposures. And so I was a little concerned when 1,1-dichloroethane was being transferred to a 1,2-dichloroethane assessment, in that if that was a significant exposure, perhaps it diminished the risk of 1,1-dichloroethane. And I didn't know if that came up today, and I also was curious as to whether any of the other committee members shared that concern. So anyone on charge question 1, I think Ms. Jenkins was the lead on that.
It did not come up in our comments, so.
Well, I guess for the committee and for those on that question, think about whether that's a concern that you have, and if it is, please let Ms. Jenkins know, because that's one that I have. And it could be that the way the assessment's done, that it's not that big of an issue. It might be a minor use, and it's better to sum that as a 1,1-dichloroethane impurity because they're analogs. And I don't want to put EPA on the spot right this instant with that question, but that is something that if you can help clarify would be good, is whether that's a minor enough component in the 1,1 that it seemed better to, if you will, aggregate that into the 1,2 exposure as a similar chemical.
George, can you please repeat your comment? I'm not sure that I caught it.
So the comment is that if we take 1,1-dichloroethane as an impurity out of the assessment, we may be limiting you will be limiting the exposure that is assessed for 1,1-dichloroethane. And we've talked as a committee about not removing exposures that are realistic from aggregate kinds of exposures. And so that's a concern. However, I will say that if the impurity of 1,1-dichloroethane in 1,2-dichloroethane is a minor exposure, and the 1,1-dichloroethane as an impurity in 1,2-dichloroethane is simply added in as another 1,2-dichloroethane analog in that exposure, I can understand that decision. I'm not questioning the policy decision. I'm questioning whether or not scientifically we need to have all the 1,1s together, and or if by putting it in the 1,2-dichloroethane assessment, it actually will overall be more protective. That was the question that was raised in my my mind. I probably should have brought that up a day or so ago, but I got sidetracked.
Yeah.
Dr. Malberti.
I am so sorry because like I think it's late in the day, so I don't quite understand. Let me see if I can understand your comment. Or from the occupational perspective, which I think is what we're saying, right? That EPA chose to use the manufacturing exposure assessment for this and use the uses and impurity for this 1.2 DCA, right? Using that as representative for all of the life cycle or the life stages of 1.1 DCA is a conservative approach, right? And that's kind of like what their approach has been, where like you use kind of like your worst case scenario to represent throughout. And if you don't have any risk, then you should be okay. If you have any risk, we have to refine it. So with that, and that's a discussion that we're going to have tomorrow with question 10. I think they are okay. Again, very conservative, choosing the manufacturing of 1.1. Is that what you're saying? And so when they're using as an impurity for 1.2, right? They will be representing that exposure kind of like in the realistic sense from that perspective. Am I understanding what you're saying, or I'm confusing?
I'm thinking also in terms of non-users and the general population as well. Those exposures. So I see exactly what you're saying, and the context in which we were discussing that most of the day was in the occupational setting as well.
Right.
Okay. So other comments? Okay, if we don't have any more comments, I think I'll turn it back over to our DFO to close us out. And so Ali, take it away.
Yeah. Thank you, Dr. Cobb. Thank you everyone for today's participation in today's meeting. I now adjourn today's meeting. Thank you.